Welcome back, everyone. This is Mike Gibbs from Go Cloud Architects, and we're so thankful to have you here for the second day of our live Certified Solution Architect Professional Bootcamp. We're excited to have you as part of this AWS Certified Solution Architect Professional Bootcamp, and we're thrilled to have you here. This morning, some of you joined our live stream where we talked about Cloud Architect career questions, and this morning we released a video that I'm going to post the link to this chat very quickly. The reason this video is important is in this video we tell you the steps of literally everything that you need to know to start your cloud, to get your first cloud architect job, and all the things that are necessary. So since we're doing cloud computing training, I want to make sure we give you all whatever is the necessary guidance to really build a great cloud computing career. I made a new video today on how to become a cloud architect, and I've been doing this forever. I've been helping people get their first jobs, and these are the critical skills for that. So I wanted to make sure that we provided that. Again, it's free. It's a video we released this morning. I strongly encourage you to watch this. I think it'll do a world of good for your cloud architect careers. Now that we've talked about that, we're going to get back into the cloud architect career training, and part of that today is going to be storage. So today we're going to talk about storage on the cloud, specifically storage on the AWS cloud. Now we're going to cover what you need to know for certification, but because I train architects and I train people to get hired as opposed to just passing certification exams, I'm going to try and give you a lot more of what's necessary to get hired when we do our architectural training program. So any kind of questions you have, feel free to leave them in the chat box. We're going to answer as many as we can. The format for today's live boot camp is 20 minutes of teaching, 10 minutes of questions throughout the day. If you've got friends or anyone that desires to learn about this kind of training, please invite them. And if you can help support our channel by liking or leaving a comment on the video, we can appreciate that. So let's get involved in the training, and let's begin with storage on the cloud. So the first thing I'd like to discuss is, what is storage? Long before we talk about tuning it, we always have to start with what it is, how it works, and why to use it. So let's talk about storage today. Storage is where an organization keeps their data. That's it. But when we talk about storage, I want to break it down into volatile storage, non-volatile storage, because storage is so important and it's so critical to your design. I want to make sure we discuss this. So let's begin with the concept of storage. And let's talk about the types of storage. But before we do this, I want to talk about volatile and non-volatile storage. Volatile storage is something that goes away upon a reboot. So think of the DRAM in your computer, but also think of the storage that's attached to your computing instances in the cloud. That is volatile storage. You terminate an instance and literally everything that you have is completely lost. Volatile storage. Use cases, fine, but you got to understand how it works and why to use it and when not to. Now, non-volatile storage, by comparison, is storage that actually survives a reboot. So non-volatile storage is something that survives a reboot. So something like an EBS volume, which we'll talk about, is going to be non-volatile storage. The hard drive in your computer, non-volatile storage. So when we consider storage, we have to understand what it is, how it works, and why to use it. Because as cloud architects, we're systems designers, and you can't design what you don't understand. So we're going to go really deep in talking about storage technologies today. So let's talk about block storage first. Because basically we're going to be dealing with block storage, object storage, file storage, but we want you to understand all of the networking. Because if you don't understand the storage, you can't design the storage. So block storage is a type of storage area network technology. So think big giant boxes, these big giant RAID arrays with hundreds of hard drives connected to the back of these servers, typically speaking with fiber channel cards. So block storage, big storage area network technology. Now, what's interesting about block storage is because first it's network attached storage, so the network will be your performance limitation when you're dealing with block storage. But block storage takes your data and it breaks it down into these little mini pieces called blocks. And the good news about block storage, which is why it's so fast and efficient compared to things like object storage, is that block storage can be placed anywhere in the environment that makes sense. So you can place it where it's fastest, you can place it where it's most efficient. When you're dealing with block storage, you're dealing with a highly performance-oriented type of storage area network, at least the best that you get. But because your data gets placed into blocks, and the blocks can be placed anywhere in your network, it effectively decouples your storage environment from your servers. So when you think about a cloud environment, When you've got an EC2 instance, for example, and it's attaching to block storage, that storage could be anywhere. So understand where it's stored could be anywhere, but you're attaching it to the compute instance, which is nothing more than a virtual machine, and you're making this virtual machine attached to the storage, and it looks and feels like it's local storage. It's not local storage, it's network storage. And if you don't have enough network performance, your block storage performance is going to be terrible because it's related to network storage. So understand that block storage is network storage, but block storage is scalable. It decouples your storage environment from your host, and it's very simple and it's very elegant. Now, block storage is non-volatile. Now, the last thing I want to talk about block storage is it's very versatile. You can store anything you desire in block storage. Operating systems frequently changing files. Block storage is widely useful for a tremendous number of different things. Wonderful. So now let's talk about another kind of storage. And we'll get into the specifics of EBS volumes and S3 in real depth, but that's not good enough. If you're an architect, you need to be a system designer. And you just can't design things that you don't understand. So we're going to talk about how things work long before we talk about the AWS specific configuration things. So please be patient, it's coming. The next type of storage environment is something called object storage. What is object storage? Object storage is another type of storage area network technology, just like block storage, but it's different. See, the thing with object storage is you take your data and you break it down into objects. Where with block storage, you take your data and break it down into blocks. But object storage is broken down into objects. Now, this object thing is really cool because when you're using object storage, you're basically breaking it down to an object, and the object's going to have its own unique ID. But it's not just a unique ID. Each object has metadata. Now, metadata is basically data about data. And because when you're dealing with object storage and you're getting metadata about each piece, you can do some really cool things. For example, you can create a data lake, which we'll talk about later in the process, which is basically integrating your databases and your storage and creating an environment where you can search and query and do these things. And you can do that because of the metadata components of it. So object storage is really cool. And it's that metadata that makes it so special. You can run SQL queries on it. You can integrate it into environments. Now let's talk about the problems with object storage. First and foremost, it's not too fast. So it's relatively low performance compared to other storage environments. But object storage is absolutely terrible for files that change frequently. Why is object storage so good for certain things but so bad for other things? See, by nature in object storage, every time you modify a file, it creates a new version. And every time you create a new version, it creates more space. More space is either filling up your RAID arrays, or if you're on the cloud, it's going to get more expensive. So when you're in this environment, you got to really think about it from a perspective of how do you maximize the performance of your systems. Object storage is great for things like software distribution, creation of data lakes, files that don't change like static website hosting. Not useful for files that change a lot, so you got to understand that in the context of your storage and how you're using it. The last kind of storage I want to talk about before we go into the specifics of each of the services that are available for you from a solution architect perspective is first, file storage. Now, what is file storage? In your computer, you've got a hard drive. On the hard drive, you put your photos, your videos, your stuff. That's file storage on your computer. Now, if you've ever worked in a Windows environment where you map a drive, and you've got like a drive D or ERX or whatever from your network, that's also file storage. It's just network file storage, which is on Windows. It uses technology called Server Message Block Protocol. You could also create a Linux server and create an SMB or Samba share, which would integrate for Windows file storage. Now, let's also say you're using a Unix environment. They also have file storage, either the hard drive in the system, or you can do network file storage. So if you've got 30 or 40 Linux machines or Unix machines and they need to access the same data, no big deal. They're going to pull it from a file storage, and when you're using Linux, you're going to create something called a network file system, which was invented by Sun Microsystems a long time ago, and that's how Linux systems and Unix systems access file storage. So at this point, we covered the types of storage environments that exist, but now we're going to get into the fun. Now we're going to start talking about some AWS storage environments, and we're going to start with our absolute favorite, because it's so widely used for backups and recovering and all kinds of cool things, is S3. So now we're going to go into S3. So what is AWS S3? object storage on AWS. Why did I spend some time talking about object storage? If you don't know what object storage is, you will not understand what to use which service at the time. So S3 or Amazon Simple Storage is just object storage on the cloud. Now, object storage in AWS is integrated into so many environments. Website hosting, database backups, system backups, machine images, software distribution, data lakes. It's used for so many things. So we're going to spend a lot of time talking about Amazon Simple Storage. One thing to note, this is relatively high availability storage. I mean, not super high availability, but it's relatively high availability, meaning 99.99% of the time, which is about 52 minutes of downtime per year or lack of access, which is still pretty high, but it's relatively low in the grand scheme of things. Now, what's really special about S3 is its durability. So while availability refers to having it available when you need it, durability revolves into, is it going to be there? So, for example, with AWS S3 at 4 nines availability, you won't be able to access your data roughly for 52 minutes a year, which is a lot, but for most organizations can tolerate that. But your data is not going anywhere. Even if you can't access it for an hour once per year, your data is not going anywhere. It's 11 nines available. That means 99.999999999. So percent durable, meaning it's not going anywhere. They back it up and they've got such redundancy that your data is very safe on AWS. So before we really spend a lot of time talking about S3, I told you that it's object storage. So what is object storage used for? So we're going to go architecture first, and then we're going to go to the technical weeds. You start architecture first because architecture is design, and we train architects, so that's really what we're going to focus on. So let's start with the use cases. Backup and archival of an organization's data. One of the primary uses for S3. It's fantastic for static website hosting, and we'll be talking about CloudFront and static website hosting, but if you wanted to just host a website, basically has a couple files and they don't change, S3 is a great, cheap way to do it. Fantastic. Distribution of content. Large videos that are going to be downloaded, not modified, software, media. Wonderful, wonderful, wonderful use case. Disaster recovery planning. Take what you have here, move it somewhere else. Absolutely fantastic. And it also gets highly, highly, highly capable when we start talking about big data analytics and data lakes and big data. So the data scientists can have a lot of fun with that as well. So when we start looking at S3, let's talk a little bit of it from a technical perspective. When you create your S3 data, you organize it in something called a bucket. And each bucket is really just a container for your files. And the way these containers actually work is each bucket is basically given a full DNS namespace, which is really cool. So you can access these buckets very easily from the DNS names that come with it. Now these bucket names can be up to 63 characters. You can include letters, numbers, hyphens, periods. And I want you to understand that when you can use a delimiter, and we'll talk about that, but you can use forward slashes and backslashes with S3, what makes it look and feel like regular storage to the user. Now remember, object storage is not regular storage. It's very special. Object storage is more like a database than a storage area environment. And that basically you've got this big flat storage, regardless of what it looks like in buckets. And then you've got a database pointer to that storage. So think of object storage as kind of like a database storing things. So you can access things in S3 and make them look like folders, but you do that by adding a delimiter, and we'll walk through that through the process. It's really just a pointer. When you get this DNS name, it's a pointer for the database to access your data. It's a little bit different than traditional storage because of that. If you're going to put your things in S3, which is a great place to store your files that don't change a lot, fantastic, you have to secure your data. And how do you secure your data? First and foremost, you can create a bucket policy, which is an extremely granular way to do this. So on your policy, you're going to create basically an IAM policy, which basically says who's allowed to access what. Fantastic, fantastic, fantastic way to set these environments up. Who can do what? Basically, you create a bucket policy, and on these bucket policies, you create something based on IAM. Now, of course, if you wanted to, you could actually use basically an access control list like Windows would always recommend. You can do that, but that's basically going to be read, write, or full control, just like your traditional Unix or Windows permissions. You've got much, much, much more granular access by creating something called a bucket policy. So just understand that's how you're going to secure it. We'll talk more about encrypting your data, but this is accessing your data versus encryption. Encrypting of your data is basically what happens if the hard drive is stolen. Keep that secure. Or what happens, but this is related to how do you secure your systems by not allowing people into them. Now, when we're talking about S3, we thankfully have the ability to use the right version of S3 or object storage that's cheaper for us. And AWS gives you the opportunity to do that in something called a storage tier. And basically a storage tier is pay for performance levels or availability levels or access levels that you need. And that's all this tiering is with AWS. Pay for what you need. So what kind of storage classes do they have? They have S3 standard, which we'll talk about. We'll talk about S3 infrequent access standard. We'll talk about S3 infrequent access one zone. Then we'll talk about S3 intelligent tiering, which is pretty interesting. And then we'll talk about S3 Glacier. So we're going to start with traditional S3. What is it? It's your standard high performance, high availability, high durability object storage in the cloud. It's common, it's used for frequently accessed data, it's great storage, and that's your typical use case for these kind of things. Standard high availability storage. If you've got data that's coming into your object storage environment, it's going to be accessed a whole lot, you want to put it here. This is your environment to basically put it here. Your traditional perfect storage for most of your data, and that's S3 standard. Now, what if you need access to your data when you need it? You need durable storage, but you don't need to access your data that much, but you'd like to pay less. That's where we get into this concept of S3 infrequent access. Basically, it's much cheaper than the standard S3. You put your stuff in this S3 infrequent access, and you pay to access your data. So this is really good for infrequently accessed data because, for example, if you have to pay to retrieve your data and you retrieve your data a lot, it's going to be cheaper to use standard S3 than infrequent access. So what most organizations do is they have their data, and we're going to talk a lot more about how to set up a policy in a minute. Organizations typically may need their data for 30, 60, 90 days every day, and then maybe after that they need it for a period of 6 months, infrequently, and then after that they never need it. So we're going to talk about setting up a policy where you keep your data where you need it accessed and then move it to lower your costs. That's definitely part of the process, and we'll get there. So S3 infrequent access, high durability, high availability, but it's only there, but you have to pay to use it, so not for frequently accessed files. Now, there's a reduced capability, S3 infrequent access. We don't recommend this because it's reduced availability. But what this is basically with S3, typically your data is spread across 2 availability zones, which is really great because that means if you lose one, the other one's still safe and protected. In this case, you're only in 1 availability zone, so your data is much less protected. So there's a choice to do this. If you have infrequent access data and you care less about it, this is a good place to put it because it's cheap, but this is only good for data that has less availability requirements. Now, let's talk about moving it around a little bit. Let's talk about the concept of S3 intelligent tiering. This is a very cool service, and it happens pretty much, it's an automated service, and what happens is AWS will monitor your data, the size of your data, the frequency of access, and it will migrate it to the appropriate type of storage for you based upon what's going to be most efficient in cost. In this case, cost optimization is managed by AWS. You never want your cost in general managed by the people that are selling you things. Having said that, there are times that you actually need to. This is a pretty good service if you're not completely sure of what you're using in the data, and this will be good for most customers. For organizations that have more sophistication on their data and what they're doing and how to use it, of course they're going to be better by manually moving things and building a strategy, but this is a fantastic way for most people. Now, the last type of object storage that we're going to talk about is Glacier. And Glacier, which is S3 Glacier, is basically where you take your data that you almost never need. It's really good because the cost of this is really low. It is an amazing place to store your data. And you can get access to your data by paying for it when you need it, but you have to understand that if you need your data, it's not immediately available. generally about 3 to 5 hours waiting. So Glacier is a great place. It's cheap. It's a perfect place to store your long-term data that you don't access that often. Very important to remember, you don't access that often. You have to pay to do it, and it could take you 3 to 5 hours. Now, you can pay an expedited retrieval fee. And if you do that, that's totally fine. But understand when you do these kind of things, it has to make sense. So let's look at some lifecycle policies and what it actually looks like. So when it comes to setting up your data, remember I said you've got the S3 for frequently accessed data and your S3 and frequently accessed for data that you need when you need it, but it's not as frequently accessed, and you've got deep archival purposes like Glacier. This is what we're talking about. This is how you could create a lifecycle policy. So a lifecycle policy will enable you to place your data in an environment that's going to be most efficient. What do I mean most efficient? Exactly what you need when you need it and nothing else. So let's take this lifecycle policy that I created. It's a random policy, but it's useful for a lot of organizations. In this case, let's say the organization has determined that their data is highly valid and they need it every day for 30 days. And then after 30 days, they need it a little bit, but they're trying to save costs. And then after those 30 days have passed, they never use it again, but they want to keep it either as archival data, training data, or anything else. So here's what they do. We set up a lifecycle policy that says store on S3, standard, migrate to S3 and frequent access after 30 days, migrate to Glacier. That'll give you the cheapest access to your training. And then once it's in Glacier, we can even set up a policy to delete after a period of time. This is how you optimize your cost savings. It's a fantastic way to do things. So now, remember I told you that object storage by nature, every time you do something, it creates a new version? That's the way object storage works. Now, because that would get expensive, and literally users that would work on frequently accessed files could spend so much money on storage, AWS has done lots of things to basically make object storage not look and feel like object storage by deleting old versions of objects. So for example, with the way AWS S3 works, which is different than traditional object storage, even though it's object storage, is if I work on a Word document and I save it, and then I open the same document and I save it 10 minutes later, and I have 50 people that are all working on the same document, there's going to be 50 new versions. AWS knows that can fill up your hard drives and your storage environment fast, so basically what they do is they delete all your old versions on their end. But if you want to keep a record and an archive of all your versions, you just enable S3 versioning, and that enables object storage and S3 to work the way it's supposed to be, the way it was designed as object storage. And typically you can see what we've done in this graphic. You put a document into a bucket, versioning is enabled, and every time you modify the document, it creates a new version, version 147, 148, 149, 150, all the way through to 154. So we're going to do that. Now, you're dealing with your data, and an organization's data is one of its most critical assets. And you have to make sure that you protect these assets. And this kind of stuff is really important. So when you're protecting your assets, you want to make sure that people can't delete things. What happens if somebody was inside your business and they basically deleted everything you're doing? They could put you out of business. So generally speaking, when we're dealing with storage, what we really recommend is something in S3, something called multi-factor authentication delete. And the way this works is, let's say I go to delete something. Instantly, I get this challenge that's sent to me that asks for a one-time password or a code. Now I could be using like a Google authentication application, an RSA key ID. There's lots of applications that can generate an MFA, multi-factor authentication challenge. So I go to delete, I get a challenge. I enter the special password I have, the one-time token password. I put it in. If it's appropriate, the object is deleted. But it's giving you a safety check. Why is this so good? It is so easy to accidentally delete something, and something like this gives you the perfect confirmation. And it means if somebody hacks into your system and they try and delete something to hurt your business, no big deal. Guess what? We're still in a fantastic position because they can't delete it because it's going to send you the text. So these are really good things, and this is why we are such big fans of multi-factor authentication delete. Now, we're going to talk about some more things in S3. And when we talk about these things, really what we're going to talk about is S3 is not like traditional storage. I told you it's organized much more like a database. Flat storage, pointing to your data. So what if you wanted to create something that looks and feels like storage? And what I mean by that is I just pasted a link of something that could look like storage and another link of something that could look like storage. And when we look at this, look at that. It looks just like Unix file storage, identical. So let's say I created a bucket like that, a bucket policy that would do these kind of things, and I created these little delimiters or backslashes and forward slashes. I can make object storage look and feel like traditional storage, even though it's not. So kind of keep that stuff in mind, that S3 is flat, but you can do a lot with it. Now, there's a lot more I want to talk about with regards to S3, but we've covered so much in such a short period of time that I want to see if any of you guys have any questions on this content right now. Does anybody have any questions on this things that we've covered with S3? We want to spend upwards of 10 minutes, no more, talking about S3, and then we're going to go back to the concept. If any of you guys have any questions, ask them now, and if not, we're going to go back to the training. I just want to make sure nobody's lost. I want to give you guys the best training experience. I want it to look and feel as much like a classroom as possible. Oh, by the way, I don't expect you to be able to click on the links that I just posted to the chat. They were just sample links that I just made to just show you how it would work. So first question, King Thangs, what frequently do enterprise use RSS? Could you not use the abbreviation RSS and tell me exactly what you mean? Yes, Razwan, that link should not be working. It's just a sample that I was trying to show you. King Thangs, if you want to tell me what you mean by RRS, I'll definitely answer it. If not, I'm going to get back to the content since I don't see too many questions, which is great. I just always want to make sure that, we don't get you stuck. I hate to see you thinking that there's a gap in your knowledge. I want to answer it. I don't want anything that we do, free, paid, or anywhere in between, to put you guys in a position where you're basically not, you're lost. Reduced redundancy storage. I've not used reduced redundancy storage in any environment. I think reducing your redundancy is a pretty dangerous thing to do, so I've not worked with it in any architecture. But to be fair, typically when I do systems, I'm dealing with the world's largest companies in the world, so they would never do anything like this, but it's not very common. Sir Ken, is it possible to create folders or new areas in your S3 object storage? As far as I know, you can't create folders, you can create a delimiter which makes it look and feel like a folder. So that's what you're doing. Okay, so great questions coming in now. What would you do if your company is requiring you to do more than just design an architect role? Well, if you want to be an architect, you take an architect role. If you want to be an engineer, you take an engineering role. And I'm happy to answer that, but there are jobs that most organizations that hire architects hire architects. Most organizations that hire engineers hire engineers. The only time where there's even a crossover in these things is when it's a tiny organization and they don't really know what a cloud architect is. And I actually have a video coming out on this soon. Cloud architects design, that's it. Cloud engineers build, that's it. You got to make it for that. And if you guys want, I am happy to talk about cloud architects versus cloud engineers anytime. We train cloud architects at our organization, and because we train cloud architects, that's our main thing. I'll put a link to our program as well as a 20% coupon code if you're interested in learning architecture. Certification is 10% of the process. Architecture lessons are 90% of the process. Architecture, soft skills, emotional intelligence, those kind of things. Critically important. So I popped that in there for you guys. Derek, you're more than happy to provide any kind of training and help I can for the cloud architect community. I'm going to ask 2 more questions, and I'm going to go right back to the training. So, Abri, can you store video recordings in S3? That's exactly what it's designed for. You put a video in there, you send a link to it, and people download it. Perfect. Now, if we're going to edit the video on S3, you would never use S3 because every time you would edit it, it would create new versions and it would be a problem. Storage of videos, distributions of videos. Fantastic, S3. It's perfect for that's what it's designed for. Supero, great question. What is meant by automation in AWS? Automation is meant by you can make one thing do something. So if you had an automation engineer, someone in the sysops department, and they went and they patched the systems automatically by a Python script they wrote, that's automation. If you basically create a policy where as soon as you get a CloudWatch alarm, that it can go trigger something else through some Lambda functions to change something, that's also automation. We're going to cover that on SuperCode. That is a really great question. Okay, Avi, can you store closed circuit TV recordings? Yes, meaning you take your recordings and then you archive them on object storage, but you wouldn't be recording to object storage. It would have to be recordings that you're transferring to object storage after the fact. Next question, what level of AWS knowledge and certification will be helpful to progress your career as a technical program manager? I have a couple people that I'm working with. I've got about 5 of them right now. I get my people to the Certified Solution Architect professional level because that's basically the minimum level of knowledge that's necessary for these kind of roles. And I work on their soft skills, emotional intelligence, and those kind of things, and my students do really well. So, Certified Solution Architect professional knowledge minimum, knowledge of the network, knowledge of the data center, just like a network engineer, just like a network architect, and just like a cloud architect. Because what you're going to be doing as a technical program manager, you're going to be doing 90% lift and shift. You're going to be going from the cloud to the data center to the cloud, and sometimes vice versa. So you have to understand how all these technologies work. So that's why you need to understand the cloud and the network for everyone. If you want to be a cloud architect, you must understand the network and you must understand the data center because that's what you're designing. The cloud is nothing more than a virtualized network or a virtualized data center. Now, let's get back and we'll do some more discussions on S3. So let's talk about encrypting your data in S3. If you've got data and you don't want if the hard drives are stolen, it could cause damage to your business. This is not a good situation. And since it's not a good situation, we need to make sure that we do what's really good for the situation. So let's look at this. We're going to encrypt your data, and it's highly recommended that you encrypt your data when you store it. What is encryption? Encryption technologies enable you to do the following. It protects your data so that if you don't have the decryption key, you won't be able to see it. So it's super important to encrypt your data to keep it safe. So that's why these things are so important. And yes, Anurag, we do include network and data center training in all of our courses because it's so critical. But when you encrypt your data, it makes it safe because you can't read the data if it's not encrypted. So let's talk about ways that you could actually encrypt your data on S3. Now you can use what's called the Customer Managed Keys with AWS Key Management System, or SSE-KMS. So Customer Managed Keys with the Key Management System is SSE-KMS. Now this is really cool because it's a complete key management solution. Basically the way this works, the user manages the master key, and the key management system manages the data key. And the key management system is really great, and then it's going to provide an audit trail of how, who, and when the data was accessed. So this is a very automated key management system. It's very easy to do. You pick the master key and AWS manages your data keys. Great way to secure your data. Your next option is SSE-S3. Now this is the easiest option, but you're giving up autonomy. In this option, AWS is going to manage your keys, which means they are going to do all of your key management. So all you need to do is use the system. They're going to manage your keys, they're going to rotate your keys, and what's even cooler, every object is managed with a unique encryption key. Why wouldn't everybody use this? Certain environments, certain regulatory environments mandate that you manage your own encryption keys. Like I said, architects design. They meet with customers, they find out their business, their legal, their technical, and their regulatory requirements. A lot of organizations are regulated and you can't use this SSE-S3, so you have to understand that. This is why architecture training is different than certification training. Now let's talk about customer-provided keys. Some organizations are so regulated that they have to manage everything when it comes to encryption keys. So this is the customer provided keys, or SSE-C. So, and that gives you complete autonomy over your keys, and you manage all the keys of the customer. So we covered the encryption options, so let's realistically talk about tuning S3 for optimal use. So we're going to talk, in this section, we're going to talk about pre-signed URLs, multi-part uploads, range gets, and cross-region replication. These are the things that we're going to be covering in this section, those types of things. So let's begin with pre-signed URLs. Everything that you put in S3 is private, which is great, unless you make it public. So you need to enable access. Super important. So you could provide IAM access for anybody who wants to access your systems, which works. Highly secure this way. But you know what would be cooler? If you could just generate a pre-signed URL and send it to someone. So the simplest way to share files that are stored on there with people that are outside of your environment is to generate something called a pre-signed URL. Basically what you're doing is you're creating a link for the person to download using your encryption key and your stuff. So it's going to provide temporary and secure access to your systems. So when you make a pre-signed URL, what you're dealing with is an expiration time. Because if I made a link and I posted it on the internet, I don't want people to be seeing that for the next 20 years and using it. I want to give it for a short period of time, give access to the person that needs it, and I want that link expired and gone. So let's talk about what would make you expired and gone. You create this link, which will have an expiration period of time. So how do you make it? If you make it with your IAM instance profile, you can keep that link active for up to 6 hours based upon the way you sign it. Now, if you want something longer, you're going to use the AWS token service. The AWS token service will buy you up to 36 hours. Why? Because it's using a one-time password, which is in the form of a token. It's much more secure than a password that people can just be clicking on and downloading forever. Now, let's say, for example, that you wanted to create it from your IAM user, create an IAM user. Well, that link needs to be last a little longer because, if I'm sending it to Jade or Chris or Joe, and they're already authenticated users, they have more access, so I can give them a lot more time access. And then if it's a temporary token, whenever the token expires. So look at it this way. Instance profile, 6 hours. Token service, up to a day and a half. IAM user, up to 7 days. Temporary token, whenever the token expires. So that's realistically the way these things are going to kind of work. Now let's talk really quickly about in ways you can actually improve your performance. And we're going to talk about something called multi-part uploads. So let's first talk about what is multi-part uploads, and let's talk about the challenges without using multi-part uploads. As it stands, let's say you wanted to upload a file or a file system to the cloud. It's great. Here's what's so important. If I send a 5 gigabit file, or a 10 gigabit, or a 100 gigabit file, which is nothing, to the internet, what happens if half of my file gets there and then there's some network congestion and the rest of it doesn't get there? I've got to start over again. This is crazy. Internet performance is not guaranteed. When we talked about direct connections yesterday versus VPNs, we talked about internet performance being best effort with zero guarantees whatsoever. So, zero guarantees whatsoever. So if you're going to use a multi-part upload, and especially if it's coming over the internet, too many things can go wrong. And even over the network, things can go wrong. So anytime you're building a file, working with files that you're transferring and uploading that are larger than 100 megabytes, it is recommended that you use something called multi-part upload. What is a multi-part upload? It's quite simply this. You take a file, use what's called a multi-part upload. It splits your file into multiple pieces, sends little pieces. In the end, it's going to look for the pieces and it's going to say, receive the whole file, reconstitute it in one file, and store it in S3. So it stops the problem of what happens if there's network congestion or a problem in your systems. Take a file gets broken down into multiple pieces, gets reconstituted into file, and placed in S3. This is a highly elegant solution. Best way to transfer your information on a network, especially if there's potential to lose data. Very smartly designed by AWS here. Now, let's talk about taking your data from one region to another. So with AWS, you have the opportunity to do the following. Let's say you wanted more availability and more durability for data. You could take your data in the US, and like US in the East Coast of the US, and you could then copy it to another region, like the West Coast, or to Asia, or to Europe, or anywhere you want it to be. And you could do that in real time with something called cross-region replication. So what is cross-region replication? Cross-region replication is when you take your data from one region and copy it to another region, and they synchronize real time. Why would you do this? Well, a couple of reasons. Let's talk about the architectural reasons of why you do these things. Let's say you've got users in Asia and users in America, and they're all coming to this static website basket. So let's say that's what's realistically going on, that it's coming from a static website. So the way AWS bills you is stuff comes in, and they charge you anytime you're transferring data between regions and things like this. So let's say you've got a 5 gigabyte website, which is a lot for a website, but let's pretend it was 5 gigabytes. And let's say you were serving 150 gigabytes of data or a terabyte of data every day out of your website. That'd be a lot of inter-region transfer charges, like an incredible amount. By comparison, if you just copied your 5 gig bucket from the US to Asia, then it would all be local in Asia, and it would all be local in your US consumers, and that would reduce the cost. So cross-region replication, it's basically think disaster recovery and think reducing your performance, reducing your inter-region transfer cost. Remember, with AWS, they don't just charge you to build a link, they charge you to use it too. So this is one of those kind of things that you should think about. So at this point, we've covered S3. Now, we're going to talk a little bit about instance storage before we get to EBS. And I want to talk about what that is, what's good about instance storage, what's bad about instance storage, but why in the cloud computing environment it's not very useful for most things. When you, sorry, I just spilled water on me. When you set up your system, the compute instance, which is nothing more than a virtual machine. So if anybody on an interview ever asks you, what is EC2? You tell them a virtual machine. I have seen 50% of the people not be able to communicate that in a job interview and literally lose out on the job because they didn't understand the underlying technologies. Virtualization. And an EC2 instance is nothing more than a virtual machine. If any of you guys are curious on virtualization, I can do some live teaching on virtualization. I'm happy to set up a live stream, configure virtual machines, we can build some containers, we can do it all live, and we can do it together. And if any of you guys desire that, comment virtualization training and in the description below. And if I get at least 100 users that desire this, I will do some free live virtualization training. Virtualization training is critical skills for cloud architects, and I am always, always, always happy to provide free trainings for the cloud architect community, but I need to know you guys want it. So if you guys want it, comment virtualization training and I'll take care of it. So when we talk about instance storage, let's really talk about what these things are. Let's look at the architecture of your systems inside of AWS. Look at it this way. Most organizations at this point that need servers and do a lot of virtualization have standard on these new AMD EPYC servers with these 64-core CPUs and a couple of terabytes of RAM, and that's what they're sticking on almost all the servers. Amazon uses them, I use them, everybody uses them now because they're the highest performing servers at about a third of the cost of the price of the Intel system. They are amazing. So when you get one of your, if you go to AWS and you're looking at one of their server racks, you see these systems, and these systems are these big, beefy 120 core or more servers, a couple terabytes of RAM, and they have storage on them. And the storage they actually have is basically a whole bunch of NVMe drives in a RAID environment. And they get 10 million IOPS on one of these systems. In fact, on my systems that my students use, they have 1 million plus IOPS because you can buy 1 million IOPS drive, literally speaking, for $100 at Best Buy. Now, the IOPS that's available on these servers at AWS is incredible. Think about 10 million IOPS on these virtualization servers. Now, when you use instance storage, remember, it's probably 100 to 1,000 times faster than the fastest EBS volume, which we're going to talk about next. EBS volumes are low performance compared to instance storage. Critically low, pathetically low. But EBS storage survives a reboot. The instance storage that you actually have is really, really, really critical. Because that stuff is so critical, for speed, but it loses everything. So could you imagine storing all of your stuff on an instance, then it crashes, you reboot your instance, then poof, you lose everything that your company's been working on forever? So for those kind of things, realistically speaking, that's where you're not going to use instant storage. Devil's Bane, I'm going to give you a couple answers to that in the next few minutes to learn how you can do these things, because I can and will make recommendations. So instant storage, super high performance storage, super high performance storage, but it goes away upon reboot. So understand, if you're using the storage like a bare metal server, you install the operating system, you would get 100 to 1,000 times better performance than you ever could in an EBS volume. Don't worry, not important. For right now, we're going to talk about how you maximize EBS volume performance in a minute. So I'm going to answer 2 or 3 questions that I've seen popped up in the last 2 minutes, and then we're going to go right back to the training. First question that I saw was definitely YHAM, you need to know this. Devil's Bone, give us a budget build, please. Can you use a spare laptop? No. So to learn virtualization Devil's Bone, what you are going to need is a 16-core Xeon server with a minimum of 128 gigs of RAM and 2 to 3 drives in a RAID 0 environment, because you're going to be taking the system and you're going to be literally chopping it up into 50 to 100 virtual machines. You're going to set to do what we do with our students. You're going to set up Active Directory. You're going to build your firewalls. You're going to build virtual machines. You're going to build containers, all in the same system. You're going to need NFS file servers and SAMS servers. You're going to need a bunch of computers to map to it. Then you need to basically set up an Active Directory thing for your IAM. Then you need to build the cloud, and our students all build the cloud in our program. That's the kind of training that employers care about. That's the kind of stuff that they want to see on the resume, and that's how you get it good. It's at least $1,000 for a server that can do that kind of training. Because of that, we've done the following. We used to tell people just to buy servers, and it's the right thing to do. But what we did is we created our training program, and I don't like to talk about our training too much. And inside of our training program, we give you 16 weeks unlimited access to our servers. You build your own clouds, you do all these things. And our training program, including the 250 hours of training, costs less than it would cost you to get your servers. If you are in a developing nation, some people have asked us, what do you do for servers? And for that, I created the Cloud Architect Experience program. And that is a program that is basically just server access. And again, I did that to make it a whole heck of a lot cheaper than what other people could do to buy the servers on their own. Realistically speaking, we are a company of the Cloud Architect Career Development Program. That's how we take in people. That's how we get you guys jobs. That's what we do. We are so effective at what we do, and I've been doing this for 20 years, that I received a call from one of the directors at AWS the other day. He called me and he said, "Thank you, Michael, for all you're doing for the cloud computing community." He said, "I watch your videos, I love them." He said, "Thank you so much for training soft skills, emotional intelligence, presentation skills, question skills, how to interrogate people, how to do the right things." He said, "It's impossible for me to hire people for cloud architect positions." He said, "Your training and what you're doing in every one of your videos is so close to what I need." He said, "I want your people." I've already introduced him to one of my people yesterday, and he's immediately going on for the next stages of interviews. AWS feels so strongly about needing cloud architects versus people that can just type a bunch of commands and the soft skills and emotional intelligence. They've chosen to come to my students' team call this Friday. And all the students that are going to be on this team call on Friday are going to get to speak with one of the directors who's looking for 12 people immediately from my student base. Why does it matter so much? If you train with us, we love it. If you train on your own, we love it. Make sure, under all circumstances, regardless of what you're doing, you're training soft skills, emotional intelligence, empathy, enthusiasm, and everything that's necessary to get your job. We don't make our training methods a secret. You can literally see everything we do. We have our free webinars, which we do twice per week, where we literally teach you how to get a job. We tell you all the inner workings of our system. You can do it with us. You can do it on your own. We just want to help you get that cloud architect job. That's what we care about. I made a video today on how to become a cloud architect. It is completely free. You can watch that. It's super important content. These are the videos that have caused all these people to start reaching out to us saying, "We need your graduate." So this is what's required to do it. If you train with us, we love it. If you don't train with us, learn presentation skills. Jerry Weissman's Presenting to Win, awesome. Emotional intelligence, Daniel Goldman's training is fantastic. Make sure you do it. Make sure you do good interview training. All of it. It matters more. I'm going to say this again. It matters more than your ability to configure things from a command line. They're just not critical skills for a cloud architect. Whereas communication is. YM, I focus on architecture because I train architects. If I was going to train engineers, I would focus on engineering skills. Architects do not configure. Been an architect for 25 years now. I haven't configured anything in the last 20 some years, but I will tell you that I've met with the CEOs of all of the world's largest companies, all of them. I've helped design most of the largest internet service providers in the world. I've helped design most of the largest bank systems, and I've helped design most of the world's largest healthcare organizations as well. And I haven't touched a configuration command in 2 decades. Why? Because I am an architect. There are positions, and we have a video coming out soon, where they put engineering and architecture roles. That is not an engineering role, that is not an architecture role, it's an engineering role. It's so pervasive of people not knowing what a cloud architect is that they just published it in CIO magazine. What is a cloud architect? They were that clear about publishing it because it's gotten so bad. It's so bad in the difference. So, and I'm going to answer one more question. I don't like to talk about our stuff for too long, and I want to go back to training with teacher tech. Do you want to know the difference between solutions architect training and the cloud experience training? Well, you can go to my you can go to my training page and you can look at it. Here's the difference. Solutions architect training could mean anything. It could mean an AWS certification. There is no concept of what a solutions architect is in the industry. Dentists use it, interior decorators use it. I've seen everybody use it. Construction people. Cloud architect training trains you to work on any cloud, anywhere, anytime. Solutions architect training specifically typically is how do you work for one vendor, and it's a much more limited role. Cloud architect training can enable you to work anywhere and typically pays 2 to 3 times better than solution architect training, and because it's a job that's bigger, more global, and helps you work in a wide variety of environments. So a cache res, which scenario can we use instant storage instead of block storage? In the cloud environment, you can use it for nothing, for the most part, unless you buy a dedicated host. And if you could remove the hypervisor, it would be great. Then you get true high performance skills. Cloud storage speeds are so bad. I mean, just so bad that we have to do really incredible things to try and make desk performance okay on the cloud. We're going to talk about that very soon. Did I miss anything else? And if you want to know the difference, you can go to the website that I have. Everything that I have and everything that I absolutely list is available on my training.gocloudarchitects, T-R-A-I-N. And just to let you know, Derek, the reason we created these programs is 90% of the people don't know what a cloud architect is. And then they get the SysOps associate, the DevOps associate, and all these other things. They spend a year of their time losing money. And in the end, they've got all these unrelated certifications on their resume. And a hiring manager looks like me and says, you want to be a cloud architect or an infrastructure architect? What's this DevOps slash SysOps? Do you even know what you want to be? And then we often will pass on even talking to the person because the certifications are so unrelated. We don't know what they know. We assume they don't know anything. Look good, look strong, look focused. Focus on exactly what you need to know and you'll be good to go. The last question someone asked me is a cloud architect or a cloud infrastructure architect? What it is it's someone that basically like a network architect, someone that knows everything and how the system's designed, plus heavy soft skills, heavy business skills, the ability to do ROI modeling, the ability to communicate with an executive, the ability to elicit the correct information, the ability to design things, the ability to present it to the board, the C-level executives, the engineers, and the architects. That's the job. So I hope I answered your question. Let's get back into some cool tech stuff because we're here to do tech training. And I'm always happy to talk about what we do. I love doing it. I'm also always happy to talk about anything. But let's get back to the tech. We're having a tech party today. But tomorrow morning, if any of you guys desire, and I will send out the new training program, I am going to do a free webinar. And some people that are on that call can actually chime in if they've learned anything from my webinars. We are going to do a free webinar, and we're going to tell you everything that you need to do to get your first cloud architect job. Every step, everything that you need to know. Not only that, we'll take you off mute. We will we'll ask questions. We will do anything we can to get hired. I'm going to do something I don't normally do because we've got a smaller group over here. How can you contact us and ask questions? I'm going to give you my phone number. You can text me, and after you text me, I'll text you back and we can arrange like a 15-minute discussion where we can speak. So text me when you want, and I will try and I'll have someone from my team or me reach out to you and we'll have a time to speak so we can guide you to get you to your goals. Last question is Letitia. Do we get any? Do you get any? Yeah, we give you certificates and we do everything that we need to do. Our program is typically about 16 weeks, the career development program. And that's about our average time from the time we take somebody in to the time they get their first cloud architect job, in most cases. I will come back and answer some more questions, but I want to get back to the tech. Again, you have my phone number, you have the links to our programs, and we would love, love, love to speak with you. So now we're going to talk about the next type of storage in the AWS environment, and that's block storage. Now, block storage is what you're going to be using for pretty much everything in the cloud. So let's go back and let's talk about some block storage. We're going to have some fun with this. So block storage is where you're going to store your things in the cloud. So versus object storage, which we'll talk about in a minute. Damien will, if we get enough, we'll definitely happily do some virtualization training. So let's walk through block storage. Block storage, as I mentioned, was a type of storage area network technology that takes your data and breaks it down into blocks, which is pretty darn cool. And it acts like a virtual hard drive. And this is what you're going to use to store things because it does not go away with instance reboot. You reboot your systems, you terminate your systems, anything that's stored on block storage will still be there. Whereas with instance storage, it's not going to be there. So realistically speaking, this is what you have to use. It's going to act like a hard drive, and it's going to look and feel like a hard drive to the system that you're using. Where does this get really cool? Because it looks and feels like it's a local hard drive. It scales well. And we'll talk about how great EBS is, but these EBS volumes will literally scale to any size you need. So for any of you guys that were infrastructure architects like me, where we're building the network and we're doing our capacity planning, and after we're doing the networking and our capacity planning, we run out of space, then we got to come up with a new architecture, a new architecture, a new architecture. This is where the cloud shines. The EBS volumes will scale up in size as needed. So these are really great. So EBS volumes are considered to be mission critical use. They're 5 nines available, meaning 99.999% of the time, which means that volume is going to be available upwards of all but 5 minutes and 5.25 minutes per year, which is pretty good availability. Now, EBS is designed for high transaction workloads. It's the best you're going to get on the cloud. And we'll talk about the best you're going to get on the cloud, but it's the best you're going to get on the cloud. And then we're going to compare cloud performance storage options with instance storage options, or what you could actually get in the data center. And why I'm going to cover that, even though it's outside of traditional AWS training, because if you're an architect, you need to know. You need to be able to architect around the poor performance of the cloud. You need to understand what exists in the data center. So we're going to spend a lot of time on that. But understand, at least this is optimized for high performance, high transaction workloads, lots of performance options. Your EBS volumes are in your availability zone. They're local to your availability zone in case you see that on a test. And they're automatically backed up to another availability zone in case you see that on a test. So the good news is the way these systems really back themselves up is absolutely incredible. For those of you that have been involved in the tech environment like me for long periods of time, here's what I can tell you about a backup. So let's see, you've got your EC2 instance, and your EC2 instance has an EBS volume attached to it, which is where it stores data. It gets backed up via snapshot. The snapshot is a 100% identical copy of the entire drive. I want you to think about how elegant and awesome that is. It is an identical copy, literally a pure identical copy of everything on the system. So let's take this, you compare it to a tape backup solution. Tape backup, you back up a folder, this, that, and the other thing. When you need to restore it, you stick in your, if you need to restore it traditionally, you install your operating system, your applications, and then you restore your stuff from the tape. That's traditional backup. Not here. This is awesome. Takes your volume, backs up your volume to a snapshot. All you need to do, and then if something happens with your system, you take the snapshot, you create, which is a machine image, and you launch a new machine image, and everything is up and running. Poof, just like that. Fast, quick, great access. This is, again, one of the really cool benefits of the cloud. I will call out things of the cloud which it does terribly, and I will talk about things that it does well. This is a wonderful, wonderful, elegant, perfect solution to EBS backup. So now let's start talking about picking the right kinds of volumes and types. So when you're going to be dealing with EBS, you're going to choose a volume type. And the volume type that you choose is going to be based upon your performance requirements in terms of latency and throughput. And we're going to cover the difference, as well as input-output operations per second, which means latency, as well as throughput. So let's define the terms. Latency is how long it takes to access your system. Read, write, as fast as possible. Latency is how long it takes, nanoseconds, for example. How fast is this time to pull or store data to your hard drive? That is latency. Latency is determined by the number of input and output operations you can do per second. So the higher your ops, the lower your latency. I'm going to put this into context of performance. Again, I want you to understand good and bad of the cloud and all the trade-offs. The fastest, the truly fastest volume you could actually get for EBS is 64,000 IOPS. 64,000 IOPS is the fastest volume you could possibly purchase from AWS. A $100 hard drive from Best Buy has 1 million IOPS, which means that $100 hard drive is 15 times faster than the best drive you can actually get in the cloud. $100, 15 times faster than something that costs you far, far, far more than $100 per month on the cloud. Understand that's the constraint. Now we're going to talk about throughput. Throughput is the amount of stuff you can move. What do I mean by stuff? I like the term stuff. So let's say you had two vehicles going at 75 miles an hour down the motorway or highway, whatever term you like to use in your country. Two vehicles are driving at, let's say, two vehicles are driving at 100 kilometers per hour, 62 miles an hour. And you've got a Porsche and you've got a tractor trailer. Now, the Porsche's throughput would be all the stuff you can put in the backseat of the car, the trunk, the boot, whichever you call it in your country. The tractor trailer's throughput would be all the amount of stuff that you could stick in the entire tractor trailer. Which has more throughput? The tractor trailer. Which would have lower latency? Latency, you could look at how fast the car can go from 0 to 60. The Porsche. The tractor trailer is going to be slow. Generally speaking, throughput and latency are related, but not in AWS. They are not related, so they're based on the way they run their architecture. So we're going to teach you the kind of drive that you need for the appropriate circumstances. The best performance you can get in an EBS volume is something called EBS Provision IOPS. This is where you're going to tell them the necessary input-output operations per second. And these EBS volumes are based on high-performance SSD storage, and they have the lowest latency you can actually buy. And they say they're designed for workloads that require high I/O, but it's the best you're going to get on the cloud. It's good for large databases. It's good for apps that need lower latency storage. Throughput on these volumes is okay. It's limited to about 1,000 megabit a second. Where do you guys think that 1,000 megabit per second is? It's about the max speed that you can actually get on a 10 gigabit Ethernet interface. So since this is network storage and that's the fastest you can get on a 10 gigabit Ethernet interface, that's about your speed that you're getting with pre-IOPS volume. So highest performance option on the cloud, lowest latency, highest throughput. Now the next volume we're going to talk about is as follows. We're going to talk about EBS General Purpose SSD volumes, GP2. Now this is relatively good for traditional storage, general purpose storage. And it's going to give you a good balance of price and performance. It's going to be fantastic for boot volumes. Why are they good for boot volumes? Because the stuff stays there after instance reboot. And that is really cool. Your things are going to be there whether you're using them or not using them. It's going to stay past an instance reboot. So good balance of price and performance. It's generic SSDs. It's not NVMe SSDs that they're traditionally talking about at this speed. Good volume. High IOPS, but lower than the provisioned IOPS. Throughput, very, very mediocre. These things have throughput of 250 megabits per second, which is relatively slow. A $100 NVMe drive at Best Buy is 3,500 megabits per second. A $100 standard SSD drive is 560 megabit a second. Traditional magnetic hard drive is about 180 megabit per second if it's 7,200 RPMs. Low throughput drive, but it's great for transactional workloads. Where would you use these general purpose SSD volumes? They make a great boot volume, for example, on your instance. They're also relatively good for a dev and a test environment where you need some good relatively lower latency performance. You don't need to want to pay for the provision IOPS because these things are a lot cheaper. Price performance balance, relatively good option. Not good throughput, relatively good latency. So that's when your use case. You need the best, use the provision for your databases and things. For your dev test environment, use GP2 instances. For system boot, the GP2 volumes or general purpose are fantastic. Now let's talk about throughput optimized hard drives. So if you're looking for lower cost magnetic storage and you got to move a lot of data, going back to that tractor trailer example versus the Porsche, and you don't need low latency. Lots of data, you don't need to worry about latency. What you're going to use is throughput optimized drives. They're called ST1. What is it? It's magnetic storage and a RAID array. This is low IOPS because it's magnetic, so it's going to be super slow in terms of disk read write, but this has relatively good throughput. It's got 500 megabit a second, which is good throughput. For normal circumstances, this is great. This is what you'd expect to see with standard SSD speeds, and you're getting it with magnetic storage at a low price. Fantastic. Really good for frequently accessed workloads. Really good for throughput intensive workloads like moving large video files and things like that. High throughput. Excellent. There's a lot of data to store and low latency is not required. This is your choice. If latency is required, not your choice. If you've got huge log files, this is your choice. If you've got to do a lot of sequential reads and write, this is your choice. Not your choice for low latency environments. Now, the next thing that we're going to talk about is EBS code as SC1. Lowest cost, low IOPS, low throughput at 250 megabit a second. Basically, this is like the equivalent of Glacier. Use it for stuff that you don't need very frequently. Now, the next thing we're going to talk about is I'm going to go through RAID, and then we're going to start talking about, we'll take a break, and then we'll talk about NFS, EFS, and those kind of things. But first, let's talk about RAID. RAID, or the redundant array of inexpensive disks, is the way that you can improve disk size and disk performance in the most cost-effective manner. What is RAID? RAID is when you combine the speed and capacity from a bunch of hard drives for performance, for speed, and we'll talk about the various RAID levels. When you're using RAID, you might take 10, 20, 100 drives, combine them together for the speed and the capacity, but when you mount it to the computer, they're not going to know it's 10 or 100 drives. It's only going to think it's one drive, and it's going to be really, really fast. So because of that, RAID is a great way, and organizations use RAID to improve the speed, the performance, and the redundancy of their environment. We're going to walk you through the 4 RAID options that are typically used in the cloud computing environment. The one is not used in the cloud computing environment, but it's used in everybody else, including probably by AWS in their data center, and we're going to talk about that. RAID is a means to combine the speed and performance from a bunch of drives. So let's talk about the RAID options. First, we're going to talk about RAID 0. When you need disk performance, RAID 0 is the best you've got. What is RAID 0? You take a bunch of hard drives, and you take your data, drive 1, drive 2, drive 3, drive 4, drive 1, drive 2, drive 3, drive 4, drive 1, drive 2, drive 3, drive 4, all the way through all the volumes. By doing that, you get 4 times this, or you get it. If you have 4 hard drives, you're going to get 4 times the speed. Fast, fast, fast. No fault tolerance. If you're taking a file and you're splitting your file across 4 drives, and one of the 4 drives fails, you lose everything because you don't have the file. RAID 0 is super fast, but it's got 0 redundancy. Lose any disk in the RAID 0 array, bye-bye data. So when you're using RAID 0, and it's going to look like this, you're going to take your data, drive. You see block 1 goes to drive 1, block 2 goes to drive 2, block 3 goes to drive 1, block 4 goes to drive 2, and vice versa. Lots of speed, lots of performance. But if hard drive 2 fails, everything goes. So when you're using RAID 0, think backup, 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 and backup some more. Because I promise you, using RAID 0, you will run into a drive failure. It's just a matter of when. Your systems will go down, and it will be a horrible experience if you don't have good things. So we'll talk about what the types of RAID to use and when and why and how. So RAID 0 is the only way, I'm going to say this again, some flavor of RAID 0 is the only way to get acceptable performance in the cloud. I'm going to repeat this again. Some flavor of RAID 0 is necessary to get relatively good performance on the cloud. Why is that? 10 million IOPS is what I'm getting from my servers that my students work on. 64,000 is the max you can possibly get in an EBS volume. If I needed 10 million IOPS, but I don't, but if I needed a million IOPS, I'd have to put 15 IOPS RAID EBS volumes in RAID 0 just to get to the level of performance that I could get with a $100 disk drive from Best Buy. Like I said, know the strengths of the cloud, know the weaknesses of the cloud. If you need high performance disk access on the cloud, you're not going to have it. You're going to have to do the best you can, which is RAID 0. And RAID 0 has no fault tolerance, so we're going to talk about RAID 10 later. But you have to understand RAID 0 to understand RAID 10. So, enterprises don't use RAID 0 because it's too risky. The only time you'll ever see RAID 0 used in the production environment, as a rule, you'll see it on the hard drives for video gaming computers. You'll see it for video editors, like when I do video editing and I need extreme speed. I put a couple drives in RAID 0, I use it as temporary storage to work on my files, and then poof, they get off of it. But that's the only time you would ever use that. You can use it with EBS volumes, and it's a little less risky than it would be in other environments, because you can do a lot of backups of your EBS volumes quite easily, and they're perfect backups. And these aren't exactly real hard drives, they're kind of like logical hard drives. So just understand, RAID 0 in the cloud is less bad than it would be in the enterprise, but it's still too risky as a rule. So now let's talk about RAID 1. So if RAID 0 is striping across as many hard drives, let's talk about RAID 1. RAID 1 is called mirroring. What is RAID 1? You take two drives, drive 1, drive 2. Everything goes on drive 1, copy it to drive 2 in real time. Drive 1 fails, guess what? You got another one. So RAID 1 or disk mirroring provides a real-time backup. Everything is backed up, all in real time. Here's the thing, it's slow. Why is it slow? Because you're backing up a 250 megabit hard drive per second, that's your max speed. It's going to be 250, and then it's going to be the other one, 250, and you might even lose some performance due to the backup. But, highly redundant, lose one drive and it works. If it was RAID 0, you had two drives, you'd have double the speed. So this is expensive, it doesn't improve capacity, its performance isn't great, but it is highly redundant. So what does this look like? Let's go back to our chart that I drew. Block 1, block 1. Block 2, block 2, block 3, block 3. Complete identical mirror image of everything that we need to do. That is RAID 1. Now next we're going to talk about what every enterprise in the entire world does. Everybody does it, and you'll probably see it on AWS's servers. They use some flavor of RAID 5 or 50 or whatever. What is it? RAID 5 gives you an amazing balance of speed and redundancy. Most common RAID environment deployed in enterprises throughout the world, everyone uses this. And RAID 5 basically takes your data and it provides a combination of speed performance and redundant. Basically every enterprise is using it. But it's not recommended by AWS, and we're going to, after we teach you about this, we'll tell you why it's not recommended by AWS. The way this typically works is, let's say you have 4 drives, you take your data from, it'll be block A, you'll take data, the first block will go to the first drive, the second block will go to the second drive, the third block will go to the third drive, and then there's this stuff called parity, which we have listed as parity A. That's data to, basically if we lose one of the hard drives, to fix it. Backup data. So then we have block 2, parity data, block 3, and what we're doing, as you can see, is we're cycling through so that every hard drive we have, if we have 4 environments, we'll have 3/4 of the data and 1/4 of the data necessary to reconstitute the information. So this RAID 5 is pretty cool. We've got hard drives. If one of them fails, all we do, pull out the drive, pop out a new drive. We typically push a rebuild button and it copies the parity data from those other drives to the drive, and poof, you're up and running and all your data is restored and everything works and you get speed. Everybody across the world uses RAID 5 or RAID 50 or some flavor of this. Best and highest performance, highest redundancy to be used for everyone. Why don't we use it on the cloud? There is some latency overhead from writing all this parity data. It adds latency. In an enterprise environment, dealing with regular hard drives, not a problem. The latency it adds is minimal, and the redundancy is worth it, and the speed and throughput is incredible. Why is it not good in the cloud? If all you have is 64,000 IOPS, which is horrible, I mean horrible, and that's the max you can get, we can't afford additional latency from RAID 5. That's why AWS does not recommend this. In your data center, RAID 5 is perfect, but not in the cloud, because you only have 64,000 IOPS max, which is terrible. I mean, literally terrible. It basically is the kind of performance that you would get 10 years ago on a computer system. So terrible, terrible, terrible. Actually, 10 years ago, you'd still get better disk performance on your computer. It's just terrible. So when you have to use EBS, and that's your only choice in the cloud, RAID 5 is not a good option because your IOPS is already low. But block storage is what you're going to have to use in a cloud computing environment. Why am I still talking cloud computing? Why do I still love cloud computing, even though I can tell you and do a better job in the network and the data center? Auto-scaling, agility, scaling up and down on demand. These things are so amazing that it makes it worthwhile. Because of that, the cloud is terrific. But you have to understand the trade-offs. As an architect, you need to say, can't bring this to the cloud, keep it to the data center. Can bring this to the cloud. Oh, I need to bring this to the cloud. We need a lot more disk performance, and how are we going to do it? So how are we going to get acceptable disk performance in the cloud and not have all of our systems go down if we lose a hard drive? I'm going to tell you, that's called RAID 10. So if you can afford it, and this gets real expensive, but if you can afford it, RAID 10 is a combination of RAID 0 and RAID 1. So basically the way this works is you're going to have two RAID 0 array, you're going to have a RAID 0 array and a backup RAID 0 array. So in the primary RAID 0 array, you're going to get the speed, the capacity, and the performance you desire. And in the backup array, you're going to get a complete and total backup. So RAID 0 mirrored to another RAID 0 array. High speed, high redundancy. It's becoming incredibly popular on the cloud because it's your only option for good performance. But it's expensive. Why is it expensive? Because you need double the number of drives. So if you need 15 PIOPS volumes to get to the equivalent of my $100 Best Buy drive, then you need 15 to back it up. So you might need 30 times. So that it can get expensive really fast. So high performance, phenomenal in every way, shape, or form. But just understand that when you're dealing with RAID, it helps your performance. So this is what it's going to actually look like, RAID 10. We've got a RAID 0 environment. You can see we're striping, and then we're backing it up to another one. So RAID 10 is a combination of RAID 1 plus RAID 0. What are your options? RAID 0 is basically stripe, data. Super fast. RAID 1, copy data from drive 1 to drive 2. So you can see, let's say, so drive 1 to drive 2. RAID 5, data from the first drive, data to the second drive, data to the third drive, parity data, and vice versa. RAID 10, RAID 0, backed up by RAID 0. Now you know the types of RAID. Any quick questions on RAID before we move into EFX and other types of file storage? Or PIOPS volumes or anything like that? I want to make sure you guys really understand. You're doing good, you're learning good. I want a real classroom-like experience for you guys. I know there's approximately a 30-second delay between the time I ask questions and the time you guys see it. So let's make sure we kind of cover those concepts. I'm waiting to see if any of you guys do this. While I'm waiting, I've received a message from my partners in the organization, and they told me that I should include a link to our career development program. So I'm going to do so, and then we're going to start answering questions. So keep the rest of my team happy by doing this. The question is, why is it different than RAID 1? Okay, Derek, if you're asking why RAID 10 is different than RAID 1, that is an exceptionally good question. RAID 1 basically takes one hard drive and mirrors it to another hard drive. Which means if you've got hard drive A that's 10 terabytes, hard drive B has 10 terabytes. There is no improvement in capacity. RAID 0, if you've got 10 terabyte drives, you get to combine the speed and performance of all 10. So you write to the first drive, second drive, third drive, fourth drive, fifth drive, sixth drive, seventh drive, eighth drive, ninth drive, and 10th drive. So you get 10 times the capacity because you're using all 10. Think of it this way. Let's say you had 10 drives in a RAID 0 environment, or let's say you have 10 friends and you want to push a car. How much faster could your 10 people push a car than a single person push a car? What you're doing is you're doing effectively parallel processing for your hard drives, and that's why RAID 0 is so fast. The problem is with all this parallel processing with RAID 0, if any one of them fails, any one of the 10 drives or your 10 friends, let's say you have 10 friends that are passing a car and one of them falls on the ground, In RAID 0, the car stopped moving. That's the difference. Derek Houston, did I make that clear for you? Please let me know in the comments section. If I did, great. If not, I will draw some charts or do anything I need to help you get better knowledge. While we're waiting for Derek, does anybody else have any more questions? Because I want to make sure we give you guys a really great training experience. Okay, I'm going to wait a few more seconds because there's a 30-second delay. Okay, you got it. I'm so happy. Devil's Bane with RAID 10 is one set of I don't know what you mean by RW, but RAID 10 is simply RAID 0 that makes an identical back up to another RAID 0 volume. So double so speed, copy everything speed, and then copy it to someone else. Identical copy. Whatever's in the first array gets copied to the second array. So Devil's Bane, all the drives in the single RAID 0 array are read-write, and all the drives in the backup array are read-write. So that's really all it is. It's just a primary and a backup. Did I answer your question there? I'm going to make sure I answered your question before going back to content or anything like that. Wait a few more seconds, and then we're going to start talking about EFS and then file systems. Okay, so we'll if need be towards the end, we're going to have in the end we'll have a lot of question and answer sessions, and if anybody needs, we'll find a time to go back to things. But it sounds like you basically got it, which I'm happy about. So let's talk about EFS. So when you're dealing with a cloud computing environment or any type of network environment, what you're actually dealing with is file sharing. Now, when you're using Linux or Windows systems, they use different sharing protocols. Every Linux system and Unix system in the entire world, for the most part, when they share files, they use something called the network file system, which was invented by Sun Microsystems about 20, 30 years ago. It's an old file system. And in the cloud, if you're dealing with Unix and Linux systems, you need NFS because that's how Unix and Linux seems. So Amazon offers you their own branded version of their NFS, and they call it an EFS, or Elastic File System. Basically speaking, it's NFS, the network file system that's existed for the last 30 plus years. Now, when you're dealing with it, it is what you would consider to be POSIX compatible storage. What I mean by POSIX compatible storage is it works with old legacy systems. So EFS will work with anything that NFS would work with because it's really much the same thing, but it's the Amazon branded version of EFS. There's two versions, like anything else in AWS. There is your standard, which is your normal best performance, and then there's your infrequent access, which is low cost storage for files that are not accessed. Let's look at your two ways that you could do this. You could conceivably set up a Linux server on a virtual machine, mount a giant EBS volume to it or a RAID array of EBS volumes and do an NFS share directly off of that thing. Or what you could do is you could purchase EFS, which is just a managed service version of NFS for you to store your data. So just think of EFS as NFS, nothing more, nothing less. Pretty simple. Like I mentioned, it's POSIX scalable. It's as high a throughput as you're going to get on the cloud. It's as high IOPS as you can get on the cloud, which means the lowest latency. Now this is really elegant. These EFS volumes scale on demand. So again, for people like me that have been working around for a long period of time, working in tech, they're capacity planning and changing servers out and adding storage constantly, you don't have to worry about this here. This is where the cloud shines. That agility, it just makes it so beautiful. What does it look like? You use this managed storage service, EFS, which is basically NFS. Like I said, you could just basically set up, if you wanted, you could do it yourself on the cloud too. You set up EFS and then all your Unix systems mount to it and they use it as shared file storage. There you go, that's the way the shared file storage works. Now, let's talk about what do you do with Windows clients? Well, a couple of options. You could easily do the following. You could set up a Linux instance, match an EBS volume, and set up a Samba share. That's what we do in the data center, because very few of us actually use real Windows servers. Why do we not use Windows servers? They're expensive, there's licensing fees, and Linux servers with sandbox shares is much cheaper and more reliable as a rule, so most of us basically use Linux Samba. But you can also use Windows servers, and if you have heavy-duty Windows workloads in your environment, meaning SQL type things, heavy virtualization environment, if and when that happens, then guess what? You need Windows file servers, like for Microsoft SQL, Exchange, those kind of things. So AWS gives you the option to buy these hosted high availability Windows file servers. And basically they just use the server message block protocols, and they're hosted Windows servers, that's it. And that way you can do any of your file systems, Active Directories, quotas, literally anything that you can do. Anything that you could do in a traditional Windows environment, you can do in these because they're just Windows servers. So Amazon FSx, if you see it on an exam, is servers for Windows, and that's realistically it. So now let's talk about getting your data to AWS. You've got to get your data there somehow. Now there's a lot of ways that you can get your data to AWS. You can transfer it over the network. And if you've got enough time and enough network bandwidth, this is going to be an exceptionally good solution. But what if you don't? What if you don't have enough network? What if you don't have enough bandwidth? What if you don't have enough performance? Then you're going to need something different. First, we're going to talk about getting it over on the network, and then we're going to talk about the other options. To get your data over the network, you're going to use something like a storage gateway. What is a storage gateway? Let's talk about it. When you're migrating your data center to the cloud, or you're doing a hybrid environment, you've got to get your data there somehow, because what good is everything you have if you don't have your data? Your data is everything. So what do? You basically set up a storage gateway. A storage gateway is a virtual machine, which we're going to call appliance, that you put in your data center. And typically speaking, you're going to put it on a VMware ESXi server, and you're going to mount your local computers to the device, then it's going to copy stuff to the cloud. And it is a really great way to deal with a hybrid environment, and it's also a great way for disaster recovery. So you put this virtual machine in your data center, you mount it as if it's a regular server, and then asynchronously copy stuff to the cloud. It's kind of an elegant solution. So when you're dealing with this, you've got a couple different kinds. You've got a file gateway, and you've got these VM gateways and stored mode and cache mode, and we're going to talk about all of it. And we'll talk about tape gateways and backup. So let's look first at the storage gateway. It's an appliance, like I said, a virtual machine, and it acts like a file server. In this machine, you can connect to it with your Windows host via SMB or the server message block protocol. You can connect your Linux systems to it via NFS, just like anything else. Server sits in a virtual machine, put in your data center, and you mount these drives. And when you put your data on these drives and you mount it like a server, it gets copied to AWS S3. So it becomes an object in S3 for you. And when your things are stored as objects on S3, guess what? They're already there. They're encrypted already there. And then once they're on S3, you can do whatever you need with them. So architecturally, this is what a storage gateway looks like. Basically, you've got your servers sitting in your data centers. They mount via SMB for Windows or NFS for Linux. It takes your direct connection or your VPN connection, and it copies your data over to S3. And from there, you can run any lifecycle policies you want in your own data. But it's a great, 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 simple, elegant way to back up your data and get your data to the cloud. So now let's talk about VM gateways. There's stored mode and cache mode. We're first going to talk about stored mode, and then we're going to move over to cached mode. So in a VM gateway and stored mode, it assumes that 90% of your data is sitting in your data center. And this is, realistically speaking, the same kind of appliance. You're going to mount the appliance, and it's going to move your data over to the data center asynchronously, and it'll all be backed up as an EBS snapshot on S3. So when your hosts are using this, they're going to mount this device via something called the iSCSI protocol, which is basically SCSI over an internet protocol. So that's all that really is. And what this is going to look like is as follows. In this particular environment, your users access the systems. The application servers mount to the storage gateway virtual machines that you have, copies it to the AWS cloud as a snapshot, backing up your stuff constantly, nonstop. What an elegant solution. It's really terrific. Now, let's say most of your data is actually stored in the cloud. Now this changes things. If your data is stored in the cloud, and hosts cannot use object storage as if it's real storage, it's just different. Object storage is very different than block storage or file storage. So hosts can't really map to object storage and use it as a real drive. But with a VM gateway, they can. So let's say you're an organization and you keep your data in the data center, versus your environment. So if your data is in the data center, in the cloud, and you're working out of your data center, how do you pull the information from your data center to the cloud? That's where this VM gateway cache mode works, and it is really elegant. So if most of your data is in the cloud, we're going to use the storage gateway in the reverse mode. What we're going to do is we're going to basically use the storage gateway to pull information from the cloud, and then our hosts are going to mount it via iSCSI, and it's going to make S3 or object storage in the cloud look and feel just like local storage or file storage. So this is going to kind of remove the object storage feel out of the object storage in order to do that, to help all of you pull your data from the cloud to make it look this way. So when you're dealing with this, all your data is going to be encrypted with server-side encryption, and your data from your data center is going to be local to your cloud. So what does this look like? In this VM gateway cached environment, look at it this way. Pretend your data is sitting in S3. And your VM gateway is in your data center. Your VM gateway is mapped to this thing. Now, here's the way it works. Let's say you've got a user that pulls information, a user that requests some information, which is actually stored on S3, but the user doesn't know that. The user with iSCSI makes a connection to the gateway, and then the gateway provides the information. The gateway, if it doesn't have the information, it goes to the cloud, pulls it from the cloud, and goes back to the storage gateway, and then sends the information to the user. Now, the second person that requests that information is going to go to the gateway, and it's going to say, I have it, and it's going to send it to the user. So, have we ever seen anything like this before? A VM gateway basically is a content delivery network and a caching system for your stuff that's stored in the cloud. And so it's the combination between using a caching environment to improve the efficiency of what's stored on the cloud, and at the same time that it's doing that, it's actually making object storage in the cloud feel like local storage. So I hope I explained that relatively well. Now, very simple, very elegant, but of course, if you copy stuff to your data, it'll also copy it to the cloud. So the VM gateway in cache mode is predominantly for your data that's stored in the cloud, but it does allow bidirectional communication and storage back and forth. Keep your data synchronized, keep your data accessed. Elegant, 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 wonderful situation on the cloud. So now let's talk about tape gateways. So for those of you like me that have been around for a long, long period of time, and when we're around for a long period of time, we work on tapes. What did we do with tapes? We basically backed up our systems to these huge capacity tapes. We changed tapes periodically when the tapes were out of capacity, and then we store these tapes somewhere secure, often off-site, in a fireproof, waterproof container to make sure that if anything happened, we could restore our data. Tape gateways or tape storage is still pretty common in the enterprises that have large amounts of data, because as a tape backup, it's a relatively low-cost way to back up your data. So what did AWS do? They took a way to work with your current tape backup appliances, and they created this virtual tape environment. So for organizations that have these big tape storage backup environments, they're going to take the backup, they're going to basically copy it to the cloud, and instead of using a tape, it's going to create a virtual tape, and it's going to copy it to the cloud. So it's going to connect to the tapes via iSCSI, just like everything else, and then it will take the data and it will back it up to the cloud on S3, and then once it's on S3, you can move it to Glacier or Deep Glacier. It's a relatively excellent way to truly, truly, truly get your data to the cloud in a low-cost environment. Here's what it's going to look like. So you take your data, you're backing up your data, you basically have your tape gateway, and it's going to copy it to virtual tapes on S3, and then once it's on S3, you can do anything you want with it. That's pretty much the way the tape gateways work. Simple, elegant solution. So now, we've got a couple more, very few things before we get into computing things to cover. We're going to cover the snowball, the snowmobile, and the import-export service. Then we're going to stop for a few more minutes of questions, and then we'll start talking about computing on the cloud, which is a thing that I love talking about. So, first thing we're going to discuss is the snowball. Let's say you've got a lot of stuff to get to the cloud and you don't have a lot of network availability and you don't have a lot of time. If you've got enough time, enough network connections, you can move any amount of data you desire, anywhere, anytime. But if you don't, you're not in a good position to do these things. Because of that, AWS, and this is a very smart option, came up with something called a snowball. What is a snowball? It's a highly ruggedized container. The highly ruggedized container is filled with lots of hard drives. So AWS has this ruggedized hard drive / high performance computing system. They ship it to you. You can get either a 50 gig version or an 80 gig version. Now, mind you, there's overhead from formatting. So the 50 gig version is about 42 terabytes that's usable. I think it's about 40 terabytes that's usable. The 80 terabyte version has 72 usable terabytes of options. It's got a 10 gigabit networking card. So what do? You plug it into your system over the 10 gig link, you copy your stuff, and then you move it to AWS. So here's how it works. You request a snowball from AWS, you copy your stuff on it, you call AWS, they get shipped back to them, they take your data on S3, and then when it's on S3, you do whatever you need to. Great way to get your data to AWS in a fast environment. Next option for getting your data to AWS is something called the snowmobile. Now let's say you've got a big bank with a ton of data and they decided that they're going to all go to the cloud by tomorrow because of some reason. This is where the snowmobile comes from. So if you've got petabyte after petabyte after petabyte of data and you have no time, you call AWS and they ship you a shipping container, which is basically on a truck or trailer with hard drive after servers. It's a big, huge data center on wheels. You plug it into your systems, you copy your data onto the snowmobile, which is basically a shipping container, and then the snowmobile is driven back on a tractor trailer to AWS, and it's going to take up a whole tractor trailer, and then it's copied to S3 by the AWS personnel, and then once your data is on S3, you can do anything you want with it. That is the concept of the snowmobile. The last transport service to get your data to the cloud is something called the AWS Import-Export service, and let's talk about what that is. Basically, the Import-Export service is like a mini snowball. Basically, it's a rental hard drive from AWS. You copy your stuff to the hard drive and you ship it to AWS. That's it. AWS, after it pulls the information off of your hard drives, sticks it into your environment, and poof, everything works and you're in great shape. That is the way these environments work. Now, in any of these environments, the snowball, the snowmobile, and import-export, you must encrypt your data and it happens automatically on these devices. Why is encrypting your data so important when you're shipping it? If your hard drive gets lost, you don't want anybody to be able to read your data. If your hard drive is stolen, you don't want anybody accessing your systems. That's why it is super important. So now you know the way these services work. Last thing that I want to cover is something that, just in case it pops up on an exam, I want you to know. There's this concept of Amazon Work Docs. What is Amazon Work Docs? It's a fully managed, secure content creation service and storage. So think Google Drive or Dropbox. It enables collaboration on creative projects, document sharing, cheap and affordable. And they've got clients for Windows and Mac OS, and it meets all the compliance standards, HIPAA, PCI, DSS, what have you. So think of it as basically a Google Drive or what do you call it? Or a Dropbox. So now let's talk about what we covered in this section. We covered S3, EBS, EFS, RAID. We talked about file systems for Windows. We talked about storage gateways. We talked about the snowmobile, the snowball, the import-export service, and work docs. Before we get to computing, which we're going to do, let's take it from here. And what we can actually do is take some questions and answers, give you guys a break. We've been working pretty hard for about an hour and 40 minutes. So if you have any questions, let's try and address your questions. Does anybody have any questions? And while we do, I would like to invite all of you, while you guys are typing some questions, because there's a delay, I would like to invite all of you to our webinar tomorrow morning. It's going to be completely free. On this webinar, we will teach you everything that you need to learn to get your first cloud architect job. Certification is about 10% of the process, and that's why we give it to you for free. But there's about 90% more that you need to learn, and we'd like you to learn them. So we teach it all completely free, and we have that at 9 a.m. Eastern time tomorrow. It's normally at a different time, but it'll be at 9 a.m. tomorrow, and we'd love to see you there. So let's go through and see if there were any questions over here that were previously typed, and if any of you have any questions, please ask them now. So the first question I see is from Arif. Is NFS the same as EBS? No. NFS is Network File System is just like Elastic File System with AWS. Elastic Block Storage is something different. So if you'd like us to clarify what EBS is again, we are more than happy to do so. But I want to make sure we understood your question correctly. NFS is almost the same as EFS. EFS is the Amazon branded version of NFS with some minor tweaks. Does anybody have any more questions? Are you all having fun, or at least as much fun as you possibly can? If you can let me know in the comment section below, or in the comment section or the chat box. I want to make sure you guys are all learning and having fun. If you are, please say fun or Cloud Architect. Actually, type Cloud Architect would be a perfect thing for you to type if you're having fun. Feedback is pretty important to us. We want to make sure you guys are all happy. Okay, great to hear. Alexandra, you're enjoying it. Thank you for letting us know by using the word Cloud Architect. Are the rest of you guys having fun? Or as much fun as possible? Okay, Derek, we will go back to the VM Gateway Cache mode. I'll do that right now, but I'd like to know if you guys are happy. If you guys are happy, please type the term Cloud Architect in the chat box. Okay, awesome. Now while I go back and find my slide, I'm going to go back to the VM Gateway and Cache mode. Okay, and then I'll ask some questions. Take it seriously. What's the difference between this free course and the paid one? Take it seriously. That is a really, really, really great question. As this is certification training. Certification training basically teaches the name of the services, how they work, and why you'd use them. On our Cloud Architect training, we teach you everything that's necessary to become a Cloud Architect. This training that we're doing today is 10% of the process. The Career Development Program is a 16-week program. And in that Cloud Architect program, because you're asking the question, in this 16-week program, we cover exactly everything necessary to be hired. We teach you how to speak like a Cloud Architect. We teach you how to write like a Cloud Architect. We teach you how to interview like a Cloud Architect. We teach you how to design like a Cloud Architect. We have you build your own cloud like a Cloud Architect. We have you literally do the full job of a Cloud Architect. We have 250 hours of training in this program. We have 100 hours of live training. And in this live training, we do all architecture designs. I'll do a free architecture design class on YouTube because everybody asked me to do so. But we do about 100 hours of live on-demand design with our students. Our students by the end of this are really solid. We teach soft skills, emotional intelligence, literally everything that's necessary to do the job as a Cloud Architect. So this training covers 10% of it. The rest of what we do is very important. In the video that I released today, I was very serious. If you want to become a Cloud Architect, certification is 10%. Only 10%. The rest of it is soft skills, presentation skills, writing skills training, communication skills training, presentation skills training, learning how to deliver the different message for the CEO versus the CIO versus the CTO versus the CFO. It involves how to ask the right questions to make a design, how to present your information to the different audiences. What does the CIO care about? Literally all of it, it's all that important. Literally every piece of those components is there. Like I said, Amazon is sending one of the directors to my class on Friday because we're the only people that teach architecture training and not just configuration training. So that's how different and how important it is. I will leave a link to that as well as the coupon to make it a lot cheaper. Some of my students are actually here just because they like extra training, and I'm sure they could let you know if they're having a good experience in the program. I know Bisang did. He's actually taken my training and even passed the exam, but he's still here because whatever we do, we try and take really, really good care of our students, whether they come with us, before they get hired, after they get hired. We love our students. They're very important to us. So I'll drop a link to the program. and the coupon code, and then I'm going to get to that cache gateway because someone asked me a question on that, and I want to make sure we cover every technical question we can, because I want everyone to get the maximum experience from this free training program. So let's go back. Someone asked me about a volume gateway and cache mode. So let me go back to describing this. In this volume gateway and cache mode, what you can see is the cache mode is really about making your S3 look and feel like traditional storage. We want S3 to look and feel like traditional storage. Why is this so important? Hosts can't use object storage like regular storage because it's different kinds of storage. But what if we wanted them to? So the way this volume gateway works is as follows. In your data center, you put a virtual machine. You can see the virtual machine where it's called Gateway VM, and it's got the little red things where it says volume storage upload buffer. And what'll happen is when a user requests information, you can see the users in the upper left-hand corner from their computer. The computer then goes to the storage gateway, and it pulls the information from S3 to the storage gateway, and then it sends it back to the user. Now, if a second user goes to that storage gateway and requests that same information, it's actually going to be cached, so it doesn't have to go back to S3 to pull it back. Second user is going to go to the storage gateway and it's going to get their information. So that is the way this cache mode works. Before I move on to Abhi's question, did I answer your question there? Because I want to make sure that we answered your question. And if you guys are all having fun, if you don't mind leaving a like, it really helps signal the algorithms that we're doing a good job, so more people can see our free content. We want to provide the best free training in the world. And if you know what our free training is, you can only imagine what our paid training is because it's 100 times better. But we still want our free training to be better than any of your other paid training options on the market because we love this cloud architect community. It's so important to us. I've been an architect now for 25 years. Architecture is so important to me. It's near and dear to my heart. And I want to bring in the next generation of architects, and I want to make all of you wildly successful. So that 2, 3, 4 years from now, thousands and thousands and thousands of you all tell me what great jobs you have. Actually, I'd like my students tell me this, within 12 weeks, 16 weeks in my program. But I'd like to hear literally from all of you a year from now, 2 years from now, about your fantastic cloud computing careers. And that's why we do so much of this for free. We love you guys. We love the cloud architect community. So Abi, you asked the question on what exactly is throughput. So let's go back to the throughput. Throughput is the amount of stuff and the amount of data that you can literally move at a period of time. So latency is how fast you can read and access. Throughput is how much you moved. Throughput is measured in megabits per second. Latency is measured in IOPS. A throughput of a drive that can move 3,500 megabit per second means it can move 3,500 megabit per second. So throughput is how fast you can move data from multiple locations. By comparison, IOPS is related to latency, or how fast you can access the disk. So think of latency as how fast it takes for a car to go from 0 to 60. Let's take two vehicles side by side. The latency is how fast it goes from 0 to 60, but latency is going to be measured as inversely correlated to IOPS. If you've got a race car and you've got a tractor trailer and you take them to a quarter-mile finish line, the race car can get there faster because it's got lower latency. Now let's say you had to move a lot of data. What do I mean by a lot of data? Let's say the throughput is the amount of stuff you could put in the vehicles. How much could you put in the race car? Not a lot. How much could you put in the big giant truck? A whole lot. So throughput is related to the max amount of information that you can move in a period of time, where IOPS is how fast you can access the drive. I'm going to go back to training, but before I go back to the training, I want to make sure you understood the concept between throughput and latency. Could you let me know if you did? Okay. It takes about 30 seconds from the time I ask a question for you, the time it takes for you guys to hear it. So we'll go through that. And at this point, if there's no more questions, we're going to start talking about computing. Okay, let's start talking about computing on the AWS platform. So when you're working in a cloud, the cloud is nothing more. I mean, literally nothing more than a virtualized network and a virtualized data center. That's it. Virtual network, virtual data center. That's all your cloud is. And when you understand that, you're going to be in a much, much, much better position to design your systems. So let's, realistically speaking, let's look at what we're talking about. When you're dealing with computing on the cloud, you're really going to be dealing with virtual machines or containers. That's your only options. You're not going to be really dealing with bare metal servers. There are a few ways that you can get them, but typically speaking, in the cloud environment, they already have hypervisors on them. And because of that, you're going to be dealing with virtual machines. This is important. Everything you do in architecture is based upon your performance requirements. So if you have a virtual machine in the data center that has 64 cores and a terabyte of RAM, and it's running at peak efficiency and perfect memory utilization and everything's right, it's at optimal capacity, what do you think you need in the cloud? If you need 64 cores and 2 terabytes in the data center, your VM in the cloud needs to be 64 cores and 2 terabytes of DRAM. That's it. So you're going to size your virtual machines in terms of virtual CPUs the same way you would do it with any other virtual machine, anywhere in the world, anytime. Map your CPU cores from your current, migrate it to the data center, and you're good. Now we'll talk about auto-scaling and ways to make this more elegant, but as a rule, if it's optimally sized in the data center, lift and shift it identically to the cloud in the same way, shape, or form it is, and you're going to be in great shape. So, just think of your current systems. CPU, memory, storage, network performance, whatever you're doing in the data center is exactly what you're going to need on the cloud. No different, it's all going to be the same kind of concept. So let's work on that. So let's look at the type of compute instances. Now this is not an exclusive list, but AWS has a bunch of compute instances that they use for a variety of reasons. They've got some that are designed to be, that are ARM-based for workloads. They've got some that are compute optimized. They've got some that are designed for GPU workloads. These are things for machine learning and things that you might be using or rendering. They've got some i3s that are designed for high-speed storage for like warehousing databases. They've got some general purpose instances. Do you need to remember all these? The answer is no. Good to brush up on them for the exam. If you're going to be an architect, and we're training architects, you're going to check every single time the chart in AWS, the chart at GCP, the chart in Azure. You're going to do it every time to determine the optimal compute platform. Why? Because these things change constantly. And there's no way for you to make mistakes. You're always going to verify with the right one. Pick a virtual machine based on your CPU cores, DRAM, GPU requirements, and you're going to be in good shape. So let's talk about virtualized machines on AWS. They're called EC2 or Elastic Compute Instances. When somebody asks you on a job interview, what is an EC2 instance? Your answer needs to be, it is a virtual machine which is the primary computing platform used on the AWS cloud. If you say a compute instance, that's it, the interview's over. If you say a compute instance, it means that you don't know what it is. I mean, you've heard the term compute instance, and it's not going to impress the hiring manager. You need to tell the hiring manager, this is what it is. It's a virtual machine. When hiring managers ask these open-ended questions, we want to know if you passed an exam or if you understand the concept. It's a virtual machine. So EC2 instances predominantly are for Linux and for Windows. Now, some software developers need to compile code on a Mac. And because of that, AWS came up with these concepts of Mac OS virtual machines. What they really are is just a Mac Mini hosted on the AWS cloud. And when you're dealing with virtual machines or EC2 instances, whatever you want to call them, you can either create your own virtual machine or you can use pre-built virtual machines. These pre-built master machines come in the form of an Amazon machine image. And basically what happens is you basically take the image, you need a storage volume and an instance type, and then you pop it and you launch it. Works great. So what is an AMI or an Amazon machine image? It's just a file that basically includes everything necessary to boot a virtual machine. So for those of us that have worked with VMDK files in VMware, an AMI is basically the same thing. It's just basically a file that you can turn into a virtual machine and launch your instance. Fantastic environment. Now, like I said, you can make them. You can use pre-used ones, or you can buy them. You can make them by starting an instance with a based instance and then customize it. You can use a pre-built one from AWS, or with everything is optimized, or what you can do is you can buy one. So when we talk about getting into security, and we're going to spend a lot of time on security, when we're talking about firewalls, for example, if you need something good, meaning something stronger than WAF, because you're an enterprise and need something sophisticated, you're going to basically have to do this. You're going to have to buy a virtual machine. And in the virtual machine, you're basically going to have to buy a firewall from the marketplace. But you can't. You can't put a physical firewall in the cloud. It's not like you can walk in the door and say, I need access to the rack, and bring your screwdrivers in and screw your firewall into the rack and then plug it in. You know, it's AWS data center. It's just not going to happen. So when you need these kind of things, you go to what's called the marketplace and you buy a pre-built virtual machine that's got all your firewall or IDS systems all installed. That's it. You can buy your AMIs like from the marketplace. You can buy them with special software or software licenses. You can buy security appliances. This is the way it works. So a machine to manage is just a pre-built file that basically is like a VMDK disk file. What's part of an AMI? All the components. It's the operating system, the launch permissions, and what you call a block device mapping that attaches specifies the storage volumes. You can copy an AMI from one region to another region, which is a great environment. You can make an image or a snapshot of recovery. Great way to do disaster recovery. Look at it this way. Take your server, make a machine image of it, store it somewhere else. Something happens to your server, launch a new server from the machine image, and guess what? Everything is going to be identical to your old system with one exception. Files will be the same, access will be the same, 100% of everything is going to be the same, but it's going to come up with a new IP address, so it's going to have a new DNS name. So you may have to remap those things. But otherwise, it will be an identical copy of the machine with the exception of a new IP address because it's going to be a new instance. Now, when you're dealing with these kind of things, these AMIs, you could do it a couple ways. You could basically launch your AMI, just like you installed a new operating system. You launch your new AMI, basically you've got your AMI, it comes up, and then you basically do a sudo apt-get update for like an Ubuntu system or a Debian system, or you could do a yum update if it's a Red Hat or a CentOS kind of system or what have you. You could do that and you can get your systems up and running. But what if you wanted to do it in a more automated way? What if you wanted the systems to patch themselves as soon as they're built, maybe launch an Apache web server? You can do that, of course. What you do is you create a bootstrap script. And this is a simple shell script. Even architects like me that don't do any coding in our lives can do this in about a minute and a half. Basically, it's basically a list of the commands that you want to do on Linux, paste it into space, and poof, your systems come up, they patch themselves, they do absolutely wonderful. So this is a really great way to basically set up your systems. Bootstrap sketches are a way you can do it. Now, like anything else, you've got lots of ways where you can buy this stuff. Purchase the right program, the right way you purchase this, and your move to the cloud is going to be successful, low cost, and wonderful. Do it the wrong way, and it will be an absolute disaster, so this is really critical stuff for us. So when you buy your instance or you rent your instance, pick the right choice. And the way you can do this is basically you can buy something that's on demand, which is buy it as you need it. You pay by the second, and this is perfect for auto-scaling. We're going to talk a lot more of it. Then what you can do is you can buy something called a reserved instance. And if you know that you need a server of this capacity for 3 years long or 1 year long, this is awesome because you're going to get a very substantial price savings because you're committing certain things to Amazon. And by committing to them, they can make better investments. So basically, you're a lower risk customer. So they can charge you a lot less. And then the last option is a scheduled reserved instance, which is if you know you're going to need it for a certain point of the day. So let's talk about this again. If you have unknown capacity and you have no idea what your needs are, you're going to use auto scaling. And you're going to use on demand because it works perfectly. If by comparison, you know your demand and you know that you're going to need your systems for a long period of time, purchase a discounted plan. What is the discounted plan? The discounted plan is basically reserving some capacity for 1 year to 3 years. If you're guaranteed you need it and you give Amazon a guaranteed purchase, your price will go down. This is wonderful. So there's your instance purchasing options. Now, there's a couple more. Now, there's the scheduled reserve, which I mentioned before, but that's like if you need it every Saturday and Sunday to do a batch job, but not the rest of the week. That's what you could do. Now, there's two more systems that we can talk about. The first thing that we can do is something called the spot instance. What is a spot instance? The spot instance is AWS has a tremendous amount of unused capacity at all times. And if you want to need some compute capacity on the cheap, really inexpensively, you can you can temporarily bid in an auction-like manner to AWS, and you can get the cheapest thing that they have available, which is called the spot instance. And a spot instance is basically you bid, just like an eBay environment or auction-like environment, on unused capacity. And if your bid is accepted, you get sold unused capacity. Now, this is really great because you get really, really cheap access to high-performance computing. Wonderful. Here's a problem. If the price of the service goes above the price that you bid, you're cut off. Literally, they'll shut your systems down in a moment's notice. So, if you've got anything critical, it's not going on a spot instance. Could you imagine running a hospital and having or an investment bank and having it shut down? So, nobody would do this. What is this used for? If you've got a batch job that can tolerate starts and stops and you need the cheapest computing platform known to man, it's great. So what does it look like when you're truly optimizing your costs? A combination of reserved instances for what you know you need to get reserve, auto scaling, which means on demand, which adds capacity as needed so you don't need to over purchase, spot instances for batch jobs, a combination of all three. Just understand, in Google they call them preemptible instances. At Amazon, they call them spot instances. When you use one of these things, they can shut you down at a moment's notice. So don't put anything critical on one of these things. It's just not a good idea. So while we're talking about this, let's talk about what's called a dedicated host. If you desire, you can purchase a dedicated host from AWS, which basically means you're buying a server and it's dedicated to you. Which means on your system, you'll have system level information. You'll be able to see the CPU cores, the memory utilization. You'll be able to manage the hypervisor, your own virtual machines. If you need a host and you've got, say, something that needs a license that needs to be attached to a specific host, this is your option. This is a dedicated host. Again, not cheap because you're purchasing the entire system, but very good in security, gives you lots of control, and that's what you call a dedicated host. Now, when you get these things, your servers and your virtual machines are going to be placed and spread throughout your environment. So there's the tenancy options, which is the concept of a shared tenancy, a dedicated instance, and a dedicated host. So let's talk about what these things are. Shared tenancy by default is you come up with 30 virtual machines, probably spread across 30 servers at AWS. And on these servers, it's not just your data, it's a lot of people's data. So that's what we mean by shared tenancy. Your virtual machines are on the same servers as other people's virtual machines, but you're logically separated. Now let's say you purchase a dedicated instance. Think of a dedicated instance as effectively your own VMware ESXi server, where it's not because you're using a Nitro hypervisor, but it's just like that. It's like a server that you have where basically you can create any of the virtual machines you need on your server. That's a dedicated instance. Versus dedicated host, think of it as a bare metal server, and if you need actual access to the server, that's realistically what we're doing. So let's talk about securing EC2 access. And we're going to talk about how to do that. This is a pretty relatively easy thing to do. There's lots of ways that you can actually do this. So let's talk about securing EC2 access. So if you've got these virtual machines, you got to protect them, right? So a real security posture is going to include firewalls, IDS systems, IPS systems, DDoS protection, access lists on the routers to protect your subnets, and host-based firewalls and the such. What is a security group? A security group is effectively a host-based firewall. When you have your EC2 instances or virtual machines, you want to protect them against bad data. So what do? You use what's called the security group. The security group is basically a stateful host-based firewall that's placed on the instance, and it only allows the traffic in that you like. So by default, it's going to deny all traffic, just like all firewalls. So you're going to have to allow in exactly what you want. Now you only allow in what you want. You don't need to deny because it's implicit. So you're going to specify the source and destination address if appropriate, the protocol, TCP, UDP, ICMP, and it's going to look like any access control list or firewall rules. So for example, I can allow port 80 and port 443 coming in from any source. Or I can allow the host 10.1.1.1/24 into the subnet. This is what you're going to do. And this is a fantastic way to visually do this. And we're going to I'll tell you what I mean by stateful again, because that's a very common interview question and most people get it wrong. Getting this question wrong is something that can tank an interview in really fast. If you're looking for a cloud architect position, I want to put a little bit of cloud architect training while we're doing certification training because they're so different. So you can see in this diagram, we've got our compute instances, and we have this concept of a security group. And because we've got this instance in the concept of a security group, it's going to keep bad stuff from coming in. Now the security group is stateful. What do I mean by stateful? This is really, really important. Stateful means it tracks the connection. So in a real firewall, let's say I have a firewall in my house, and I do. I've got a very extensive, expensive firewall sitting in my home. I spent a lifetime at Cisco, so they send me a lot of their gear to test and evaluate some stuff. So I've got this firewall. When I want to go to the internet, I go through my firewall to the internet, and the firewall says, Mike Gibbs from his computer, which is 192.168.2.29, sourced an address going to www.cisco.com, allow Mike Gibbs' return traffic. Because I saw Mike Gibbs sent the request. I saw Mike Gibbs went to this web server and sent a SYN. So when the ACK and the SYN comes back from the web server, which is part of the TCP IP protocol setup package, I know full well it's allowed. Why do I know it's allowed? Because I watched Mike's traffic out and I allow it back. So stateful means that it pays attention to the connection and it sees where the connection came from. Because stateful knows, and because stateful is state, you only have to apply these things in one direction. So stateful does not mean you only apply in one direction. Do not say that on an interview. I've literally lost about 800 potential cloud architects just for not knowing stateful. Because if you don't understand stateful, you don't understand firewalls. And if you don't understand firewalls, you can't understand securities. So if someone ever asks you in a cloud architect interview, what does stateful mean? It means something is tracking the connection, something understands. Because something goes through and the firewall maintains knowledge of it, it allows the return traffic. That's why it only needs to be applied in one direction. It doesn't mean that it's applied in one direction. It means that the state is known. That's why it works with only applied in one direction. So let's talk about some more tuning of EC2 instances. How about putting an address on an instance? No IP address, no communication on the network, so this is really, really important stuff. An EC2 instance can have multiple network interfaces, just like any server can have multiple network cards. Of course, on any server where you've got multiple network cards, guess what? You need multiple IP addresses. Each network card has to be on a different subnet, so you're going to need an IP address on a different subnet. Now, when these EC2 instances come up, they're assigned a name by what's called EC2 DNS, which is DNS for EC2 instances only. And if you need a system to be reachable from the internet, you can put a public IP address on it, but otherwise, you're going to be using a private IP address because it's not going to be reachable from the internet, so it's going to be much more secure. Now, when instances come up, they're automatically assigned an IPv6 address. Of course, you could disable that if you want. And every interface, meaning every network card, needs to be on a different subnet, and it needs to be unique address space. Because if you have two instances on the same address, they can't talk to each other. Just remember that. How can you access and manage your systems? Well, the following ways. You can do it from the EC2 console, from the management console. You can SSH or secure shell onto your machines. If you're using Windows, you can use this remote desktop protocol for Windows systems. Not exactly the most secure way to access a system with remote desktop protocol, but that's the best you can do with Windows. And you can do some management via the software development kit, Think API. So what did we talk about in this section? We talked about EC2, we talked about AWS, we talked about AMIs, we talked about purchasing options for your systems, we talked about securing your instances, and we talked about EC2 addressing and then accessing and managing your EC2 instances. We've covered a lot so far. So let's take some questions. Okay, so Balwinder Kerr. How is shared tenancy instance different than any regular EC2 instance? All regular EC2 instances are shared tenancy. It's only when you want more control or something better that you're not going to be using shared tenancy. So shared tenancy, and that's a great question, is the default that actually comes for free when you're actually dealing with shared tenancy. Who has another question? Serkan asked a great question. Latency is different than network latency. So Sirkan, there are a lot of kinds of latency that we're talking about when we're dealing with the computing environment. It could be latency for the hard drives, latency for the network, latency for the amount of time it takes to get for a packet to be processed by the CPU over router. Lots, for example, that would be contributing to network latency, even though it's not link latency. So there's lots of latency. But when we were referring to IOPS, we were referring to latency completely related to hard drive access speed. Who else has a question? Stajo, I have no idea what you mean by sold or sold latency. There's latency related to how fast you can access your hard drive. There's latency related to network access speeds. I've never heard the term sold latency, so I don't know what you're referring to. Anyone else have a question? How do we manage VMs in AWS? Sirkan, it's a great question. In vCenter, it's very simple and very elegant. In AWS, basically speaking, the way you manage them is you SSH into them. You can convert it into an AMI, or you can use the management console, or you can use the API, but that's pretty much it. There's no simple, elegant way to manage your systems in the cloud as well as you would with VMware ESXi, unless you're getting into Terraform and it's infrastructure as code stuff that comes up and comes down. So, but realistically speaking, it's more of an SSH kind of environment that you're dealing with. Oh, sorry, somebody from my team translated your question on Tejo. So when it comes to different environments, as it stands normally, what you're talking about is your unshared tenancy, meaning your stuff and everybody else's stuff is all on the same system. That's why it's shared tenancy. Now you can purchase a dedicated instance, which is basically a dedicated server running the AWS hypervisors, which means you can create all of your EC2 instances on your own server and it won't have other people's servers on it. So a dedicated instance is basically when you buy a server from AWS that enables you to put all your VMs on there. But it's a server with a hypervisor installed and it's designed specifically for EC2 instances, meaning VMs. By comparison, a dedicated host is basically just the server blank. So if you're given that server, you have complete and total access to the server, the CPU sockets, the memory, everything. So basically look at it this way. If in your data center you had a real server where you just installed Windows or Linux and then you installed your applications, that's a dedicated host. If in your data center you have a VMware ESXi server, for example, and you put all your virtual machines on that, that's a dedicated instance. Where a shared tenancy is, you just create a compute platform anywhere in the environment, and that's realistically speaking what you need to do. So I'm going to give you guys some architecture training and some free architecture tips right now. When you speak to executives, don't use abbreviations. When you write, do not use abbreviations. There are 1,000,001 abbreviations that all mean the same thing. So I don't know what NFV is. I could give you some financial terms that equal to NFV. I could give you some medical terms that mean NFV, but I don't know what NFV is. So if you actually type it out, do this. And whenever you write an architecture document or you present to executives, today we're going to talk about the Elastic Compute Cloud, which is a virtual machine which AWS calls EC2, meaning Elastic Compute Cloud. Always define a term before you talk about it. Critical skill required for a cloud architect is that level of communication. So I'm giving you that guidance. Network function virtualization. Okay, that is another type of NFV, but is that what you actually meant, Abby? Because there's a whole lot of NFVs that are there. So Abby, I need to know your definition of NFV. Although it could be network function virtualization, but it could be a whole lot of other things. Literally, there's about 150 terms that use that NFV, so I want to make sure we get the right one. Sirkan, while we wait for you to answer that, does AWS provide SSL or IPX VPN service when you buy an ECN? Okay, wait a second. So these are all different things. So does AWS provide SSL or IPX VPN service when you buy EC2 instances? Of course not. VPN services are related to your access of the network. When you connect your data center to the network, you need connectivity. It could be a direct connection or it could be a VPN, and you're going to have to order that. It's a completely separate service. Network access is basically the plumbing to get you from point A to point B, and an EC2 instance is a virtual machine, so they're completely unrelated technology. I will refer you back, and I'm happy to talk about VPNs versus direct connections. Yesterday we spent about 3 hours on that, and that video is completely free. We'd love you to see it, but that's what we're referring to. Now, I covered the dedicated host for the dedicated instance. We covered okay, so Ken, so the second half of your question is related to so Abby, you're going to still have to define your version of network of NFV. Tell me what you need, because we can't answer your question until you tell us exactly what your abbreviation is. There's at least 150 NFVs out there. So just like you wouldn't write a book without defining your term, and you wouldn't present to an engineer, to the CEO without defining a term, I'm training you to be an architect, and since I'm training you to be an architect, I'm going to ask you to tell me what you mean by it, because there's lots of NFVs. So, thank you so much, Ahmed. Shukran. Can you create private VLANs for your internal? Okay. So, not in the cloud. In the cloud surveying, you basically have no control over the network whatsoever, other than a little bit of their virtualized network. So AWS does all network virtualization, and you're not going to have the control. You don't have access to the switches. Now, here's where you would use private VLANs in a high security environment, and I design this constantly. Let's say you have your data center, and you've got 3 subnets of people that are going to be accessing the clouds. We would typically put them in, so let's say you've got your data center, and you've got your users in 3 VLANs. I would typically put the users accessing the cloud in a private VLAN, and then I would also use something called 802.1x authentication. And what I would do is I would make sure when the users plug in, they're authenticated by the system using 802.1x, because if you can get onto the network, you can cause damage. So because you can get onto the network with damage, so let me start to explain this. So typically you limit the subnets that can access the cloud, and then you limit who can even get on the subnets with something called 802.1x authentication, to say it'll recognize Mike Gibbs' MAC address. Mike Gibbs' MAC address. So because it's going to recognize Mike Gibbs' MAC address, it knows to allow me on. Now the reason I would use private VLANs in the data center is as follows. If my PC were to get worm infected, I don't want it to infect somebody else's system. So by using private VLANs on our data center, we can limit the damage of who can damage each other. Now that way, when we connect to the cloud, then we can make sure that if one worm gets infected, we don't create a DDoS attack on ourselves by having 100 users in a private VLAN coming onto the cloud. But Sarkane, you have no control over anything in the cloud. You're not going to be able to look at the network. You're not going to be able to optimize the network. All network functions are virtualized in the cloud, at least what you see, but you're not going to have any kind of pretty visualizations of things like this. It's not like a data center. There's no netcool. There's nothing good for you to do these kind of things. It's not part of it. Thank you for defining the term. Now I knew what you meant, visualization versus virtualization versus one of the other 148 terms that use that term. So please remember that when you communicate with executives as part of your job as a cloud architect in the future, or anytime you do any writing, long before you use an abbreviation, you have to network it. See, we've even had people on the call actually misinterpret that because it's so commonly used. That's why it's essential always to define it long before you do it. That's why as architects, we make 0 assumptions. When someone gives you an abbreviation, if it's not clear, we ask. We must ask if it's clear, because otherwise we're going to make a design based on bad decisions. So we must get that information. We make no assumptions. That's why your soft skills and communication skills are so essential. That's why AWS is on my call. That's why they're going to be on there on Friday. That's why they asked me, and they want so many of my students. Why? Because my students know how to speak, they know how to write, they know how to ask the right questions. It's more important than your technical competency. It's that critical to know how to speak and communicate. That's why people have a hard time getting a cloud architect job. Look, cloud architect jobs are very easy to get. I get a job offer every day of the week. And it's because I can communicate well more than my technical skills. It matters more. So you have no control over SDN solutions in the cloud. Ahmed, we're thrilled to have you here. It's very, I don't know where you're at, but with your name, it could be in the middle of the night for you. So I'm just grateful that you participated. And in any case, thank you. Software-defined networking is something very different. Abby, I think you can assume that AWS is using an IGP of either OSPF or ISIS, intermediate systems to intermediate systems, or versus open shortest path first. Then you can assume that they're running some RSVP signaling. Then you can assume they have a tremendous number of MPLS-based tunnels. You can assume they're running IBGP, EBGP, and multi-protocol BGP, and a whole lot more. Software-defined networking, not so much. Okay, so we covered this. We're going to start talking about databases today because we've got about 40 minutes left. And then tomorrow, after we do that, we are going to have a much bigger, much deeper conversation on some more databases. My team has informed me that I have not posted the link to our Cloud Architect Career Development Program in a long period of time. So I was asked and informed that I should paste it, so I'm going to do so. Okay, getting back to that, now that I've made the rest of my team happy, I'm doing the things that we're supposed to do, let's talk about databases. So, first and foremost, the way I told you that you always define a term before we get something, and that way we don't make mistakes, we're going to talk about what is a database. So, a database is basically a software package that you use that enables you to store a tremendously large amount of information. It's going to enable you to sort it, calculate it, report it, and share information. Databases, I'm going to say this again, are considered to be one of the most critical business applications at this point. And why we use databases and the types of databases we choose are critically important for a cloud architect. You must know why the databases are being used, how they're used, and their use cases. So important. So we're going to talk about that from an architectural perspective. So when you're dealing with AWS, we're going to talk, realistically speaking, about 3 kinds of databases. And then we're talking about why you're going to use them. So of the 3 databases that you have access to, you've got relational databases, NoSQL databases, and data warehousing databases. Let's talk about relational databases first. We're going to get into depth, or at least some moderate depth, because I'm not a database architect, I'm a cloud architect and a network architect. But we're going to talk about databases. First and foremost, let's talk about when you would use them. We're going to begin with the relational database, which is the most common form of database and their use case, and then we're going to go back and we're going to start talking more. Relational databases are used for the following purpose: to help an organization determine the relationships between variables. That's it. Relational databases are used to help an organization find the relationships between variables. What do I mean by that? What does price do to sales? That is what relational databases help. If I run this cell, did it improve sales? If we down this ad, did it improve ads? Is the customer's phone number or geographic things related to how much they purchase? Relational databases show the relationship of variables and how one thing affects another. Why do organizations care? It helps them make better business decisions. That's why organizations use relational databases. The next type of database that organizations use is something called a NoSQL database. NoSQL means not only structured query language, meaning that it has more functionality and capabilities than an SQL or structured query language database. What's so special about NoSQL? They scale. They scale and they scale. So organizations use NoSQL databases when they have a lot of customization that needs to occur, or they need scalability beyond anything you can believe. And we're going to talk about this soon. But What do I mean by that? Let's say you've got 50 million Internet of Things devices, all over weather sensors all over the world reporting weather information every 10 seconds. Not going to be capable of doing that in a relational database, even though it would be cool. You're going to have to use something called a NoSQL database. And then we're going to talk about the last kind of database, which is used for data warehousing. And what is a data warehousing database? On AWS, it's going to be Redshift, but there's lots of versions for this. It's a place where you store incredible amounts of information. Why would an organization want to store incredible amounts of information? Quite simply, they want to take this information that they've collected over a large period of time, they want to mine the information, and they want to make better business decisions based upon the information. Think data science. That's what data science is. It's not machine learning, that's a tool. Data science is the ability to take large amounts of information, be able to look at the information, analyze the information, and make better business decisions. That's why organizations use data warehousing databases. So now that we talked about that, let's talk a little bit more about the database. Relational databases are the most common form of databases, and they provide storage and access to data that's related to each other. In the structure of these things, which we call the schema, think of a spreadsheet. Effectively, your data is stored with rows and columns, and each row is going to have a unique ID, and each column is going to have a unique value. And realistically speaking, that's the way a relational database stores and is structured. Think spreadsheet, columns and rows. Now, when you're dealing with AWS, there's a lot of relational databases that you can choose from. Relational databases are best when your data is structured. Relational databases apply to what the acronym, the ACID model, which means atomic, consistent, isolated, and durable. Wow, Mike just said a whole lot of stuff in a short period of time. What did he mean by that? It means when you do a transaction, it's all or nothing. It either gets written or it doesn't. Consistent means the second I write to the database, everybody gets to say the same things. Meaning it's instantly consistent. We'll talk about eventually consistent later. Isolated, meaning one transaction will not affect another transaction. So it's isolated. The next thing in the list is something called durable, meaning the data in the database won't be lost. So relational databases follow the ACID model. Atomic, meaning all or nothing. Consistent, meaning immediately after you write something, everybody else can read it. Isolated, in that one transaction doesn't affect each other, and the data in the dashboard will not be lost. So, going back, why are we using these relational databases? Well, you see what we're trying to hear? We're trying to show the relationships between variables. Customer orders, names, email addresses, price. We need to know this. Why? We can make better business decisions this way. That's why relational databases are so cool. Now let's talk about the relational database options that you have on the cloud. You've got basically Amazon Aurora, which I'll talk about, MariaDB, Microsoft SQL Server, MySQL, Oracle DB, and PostgreSQL. So if you're looking for a fully managed service, you can use Amazon Aurora. It's a nice, fully managed relational database service. It's got relatively good performance and scalability. And what you're trying to do here with Aurora is you're looking to get some of the commercial functionality that we would get, say, in an Oracle database, but for a database where you're not paying for licensing. So it combines the benefit of like your commercial databases like an Oracle with the low cost of something like MySQL or MariaDB or something like that. So typically people use Aurora because it's basically an enterprise relational database, software as a service kind of thing. It scales well, it's easy to use, they manage everything. This is one of your options. The next option you would have would be to use good old-fashioned MySQL. This is the most common relational database in the world. It's been out there for a long period of time. It's free and open source. And this is part of that LAMP stack that everybody needs to know, which is why we have our students all build it. The Linux, Apache, MySQL, PHP. This database is used everywhere for everything. It's free. It's got some scalability challenges, but it's an exceptionally good relational database. It's free and it's used everywhere. The next type of relational database that tends to scale well and people like is this PostgreSQL. And it's another open source relational database, and it's got a really good feature set. So think of it as like an advanced MySQL. Still all relational databases we're talking about right now, so they're all pretty similar. Then there's the very common MariaDB. This is another open source relational database. In fact, it was created by the same people that created MySQL. So think of it as like MySQL v2, lots of additional features and functionalities and scalability over MySQL, made by the same people that made the MySQL database in the first place. So love this database, played with it, done it, lots of containers, used it in lots of environments, terrific database, and it's free. Now when you're getting into paid options, you're realistically looking at the Microsoft options and the Oracle options. Most people that I've worked with use Oracle. I haven't worked with many organizations that have a lot of Windows workloads other than Microsoft Exchange and Active Directory and those sort of things. They typically use Unix, Linux servers to run everything and Microsoft servers to do those two things. Calendaring, mail, those kind of things. Microsoft does a beautiful job. There are people that do use Microsoft SQL, and it is a very elegant database to use, and it is very simple to administer compared to other databases, which is what people like. And there's an Amazon relational database service that supports lots of versions of it. It supports Microsoft SQL Server 2008, 2012, 2014. And if you've got users that are working on MySQL databases and they've got large numbers of Windows workloads, which some customers do, you're really dealing in a great environment of lots of people doing a lot of things. Microsoft has different clustering and failover options that most databases completely different. So if you're using that, make sure you understand how those things work. And there are 4 versions of the Microsoft SQL databases you can use, not just the year version, but the Express, the Standard, the Web, and the Enterprise. So if you're part of one of those organizations or you're designing something for an organization that uses Microsoft, that's your options in the cloud. Lots of options to use. Now, when it comes to enterprise databases, the king and queen of this for the most part are probably Oracle. They're one of the most popular paid relational databases in the world. These databases have an extraordinarily good feature set and functionality. Look at it this way. When a company does nothing more than make databases for a period of 20 years, it's going to be pretty darn good. So their database is great. Now they're doing cloud and other things like the rest of us are, but Oracle databases, extensive features and functionality used by pretty much all your big global enterprises that aren't afraid to pay for things. Great product. The AWS relational database has multiple versions of Oracle. It's the standard, the enterprise, the standard one, the standard, and enterprise. And you can use any of these things, and each one's going to have different performance, flexibility, and scalability needs. Now, there's 2 versions of licensing supported by AWS. You can use the license included, which basically means you buy one of the things from Amazon, you're buying their systems from Amazon, and while you're buying your systems from Amazon, you've got this, it includes their license, so you don't have to pay for the license. Now, option 2 is you bring your own license and you put it on your own host, and it gives you a lot of flexibility. You can choose the standard, the enterprise 1, enterprise 2, and it's your license, you're in charge of managing it, so you've got a lot more flexibility. You can just pop it on an EC2 instance. Now, we've introduced you to the relational databases on the system. I'm going to talk about NoSQL databases for a few minutes, and then we'll talk about data warehousing options, and then we're going to break for some questions, or maybe even break for the day. So we'll break for some questions and then for the day. So let's talk a little bit about NoSQL databases. What do we mean by NoSQL? I told you this means not only structured query language. These NoSQL databases are really great because they allow for a lot of flexibility in the schema. Remember I told you relational databases use columns and rows just like an Excel spreadsheet. A NoSQL database gives you a lot of schema flexibility and therefore can work with structured and non-structured data. Since the structure is flexible, you've got a lot of customization. Here's the thing with structural databases, with NoSQL databases, is they are really big and they offer really, really great performance because they enable you to be much more flexible. So that's one of those important things to remember, is the way these databases actually work. Highly scalable, flexible schema, work absolutely terrifically. So customization, but also more scalable. The way these things work is you partition the database and it's almost as if you created a new database. So when you're dealing with NoSQL databases, you got a lot of options. Every cloud provider has their own choice. AWS has DynamoDB, Google has their Cloud Big Table, what everybody uses in internal organizations is Apache Cassandra. Use whichever you want, and you can use any of these on the cloud. Now, on the cloud, I'm going to say this. I typically am not the biggest fan of serverless architectures. Why am I not the biggest fan of serverless architectures? Generally speaking, when you use a serverless kind of environment, here's what happens. You have to spend an incredible amount of money refactoring your applications to bring them to the cloud. And then if you bring them on the cloud and the cloud doesn't work, it's too expensive, you run into the problem with the cloud provider, you got to spend millions and millions and millions of dollars to come off of the cloud. Not with this. DynamoDB is a cloud-managed NoSQL database. It's completely managed by AWS. It's highly available, and it's going to be in multiple availability zones by default, and it's serverless. Now, typically speaking, I don't like serverless, but I like DynamoDB. Why do I like DynamoDB? It's compatible with Apache Cassandra, so it's easy to get your data in and out of, should it not work for you on the cloud. It scales. It grows on demand, and because of this, you have an environment where you're not constantly swapping out servers and you're not constantly dealing with all these things. It makes it simple, it makes it elegant, and it can scale. Love this. This DynamoDB is an exceptionally good database. Could you use Apache Cassandra on an EC2 instance? Sure, I've done it with lots of clients. Could you just set up a DynamoDB situation? Sure, I've done that with lots of clients. Elegant serverless solution, and if you want to come on the cloud and off the cloud in a short period of time, it is a very good model, so I highly recommend it, and I think it's terrific. So, realistically speaking, what's cool about DynamoDB is it's got low millisecond latency, and that could still be a lot, but it's relatively low. But the good news, which makes this stuff even cooler, is that you can actually add the DynamoDB accelerator, and that can really knock down your latency and can make it so much lower latency. So I think that's pretty terrific. Anything that you store on DynamoDB is going to be encrypted by default and can be backed up with little or no effect on database. So this is really great. And you can actually set it up for cross-region replication. So love DynamoDB, lots of scalability, lots of functionality, lots of everything you need. So the way these things work is you've got these primary indices, and your primary indices are basically your primary database. Now inside of your primary indices and your primary database, what you've got going on is you create what's called a secondary index. And when you partition the database and you create a secondary index, you can increase lots of performance. So the secondary indexes can have the same partition key as the base table. But anyway, when you create a secondary index, you can make a local or a global one. Now a local secondary index is going to have the same partition key as the base table. A global index or a secondary index can literally go across all database partitions. The only thing is you can't actually make a key value that exceeds 10 gigabytes, but that's not really a big problem. To increase the scalability, it does not follow the ACID model, it follows the base model, which means your data is eventually consistent. This means if I write data to the database and someone goes to read it, then that's how you access the information. So data is written to the database and then pulled for the database. Eventually consistent. So understand that if I write to the database, it's not going to be immediately available. Super important to know. It may take a second or 2 or 5 seconds to be available. When do you use DynamoDB? Actually, before we talk about when you should use it, let's talk about one more thing. DynamoDB can scale as needed, but there's some real limitations with that. In that you can set up auto-scaling of your systems, and when you set up your auto-scaling of your systems, they go up and they go down. That's what they're designed to do. They go up and they go down. Not so with DynamoDB. DynamoDB, you need to know your capacity ahead of time, and you need to make some smart, intelligent decisions. DynamoDB is, for example, if you enable auto-scaling, it'll scale up, but it'll never scale back down. So let's say you have a retail store that's using a NoSQL database and it's on the highest sales day of the year, and they allow auto-scaling. They're then going to be paying for the highest price for the rest of the year because auto-scaling won't scale down. So with DynamoDB, you need to provision your read and write capacity before you use it to make sure you have capacity. And if you have capacity, this is wonderful. This is the way it's supposed to be. So scale up, but it won't scale down, so pre-provision it. Now, if auto-scaling scales it up, you can manually take it down, but you need to understand that auto-scaling is not working. So when you're dealing with DynamoDB, if you're going to use that pricing schedule, you make sure you provision your read and write capacity ahead of time. If you do not, you're going to pay too much or you won't have the capacity that you need. Because it scales up, but it won't scale back down. So when are you going to use this data warehouse, DynamoDB again? When near unlimited scalability is required, when low latency is required, when you store lots of things from Internet of Things devices, game state, for example, you save in game state, player leaderboards, like for example, for Netflix to kind of store, where you're at in a video would be a great use case for DynamoDB. Financial institutions that are doing thousands and thousands and thousands of transactions all over the place. Shopping carts, e-commerce, these kind of things. Big, big, big data applications, big database applications. That's where you're going to use this kind of stuff. So let's talk a little bit about data warehousing databases. Data warehousing databases are where you put an incredible amount of stuff. So if you want to you store data from a wide variety of tools, you stick it in a data warehouse. With AWS, it's going to be Redshift, but we're just going to talk about these things. And by using these things, you put lots of data in your thing, then you can analyze your data with Business Analytics tool. Business Analytics tools can help you with these things. So they're designed to handle large amounts of historical business data. Typically, it's going to include the following components: your data warehouse. It's going to be a database to store your tools, a tool to visualize your data, and a tool to prep and load the data like an ETL tool. So big data, big storage environments, lots of work to get it in, lots of work to process it. So let's talk about the data warehousing databases. You've got your buckets, your S3 buckets, which go to Elastic MapReduce, typically speaking, and then gets put into Redshift, for example, and then you would then visualize it with QuickSight. So this is typically what you do. You basically have your systems, you run what's called an ETL or extraction translation loading tool. You stick it into your data warehouse, and then you run a tool like Tableau or QuickSight or one of these kind of things to go look at your data, or Power BI or something like that. So let's talk, so you can see what it actually looks like in this picture. You're getting your data from S3, you're copying it with an ETL tool, you're migrating it to Redshift, and you're going to visualize with a visualization tool. Traditional data warehouse that you see in all kinds of environments. This is the way your data lakes work, this is the way the environment works, this is the way things go. Data warehousing. So when you're with AWS, their version is Redshift, and that's really a managed data warehouse solution. What's cool about this is you put all your things in there, and then you can take your data and you get some actionable insights. Why are you doing these actionable insights? You're doing it for the following reasons. You want to make better business decisions, so you're going to look at your data. And so Redshift is what you're going to do, and the way Redshift works is you're going to build these clusters of computing nodes, and you're going to have one node that's going to be the leader node, and then you're going to have all these followers, which are going to be called compute nodes. They all support the leader node. Does that sound like anything familiar? When we talk about databases and we talk about the master database and the read replicas, kind of the same kind of concept, but for a different kind of database. You're always directing the main database as the leader node, so that's kind of, it's analogous but not exactly the same. But that's realistically the way these things kind of work. So when you're dealing with AWS and data warehousing, you've got a couple options. You can buy dense compute node and dense storage node, and they're different. Dense compute nodes have very high speed SSD RAID arrays, and dense storage is for if you've got a lot of stuff to store, and that's going to use magnetic RAID arrays, so it's going to be higher latency, but much lower cost. The last concept that we want to talk about today when it pertains to this is the concept of a data lake. What is a data lake? A data lake is a repository that enables you to store structured, unstructured data, literally everything you would possibly want at the same place at any scale. A data lake is where you're going to place your content. So think S3, think relational databases, think NoSQL databases, think your data warehouse, all together, sharing information between them so you can make better business decisions. The whole point of all of this is to create a data lake. And you don't even have to structure your data until you're ready to use it, but it's a place to put your data for big data applications to use for the future. So let's go and talk about the benefits of it. You can have all your data, it's adaptable and changeable. It can hold the data in live format until it's needed, and data lakes can be queried so you can search for your information. What does it actually look like? I'm going to show you real quick. You've got a data source, and a data source, and you pop it into a data lake. It gets transformed in some way, shape, or form through an ETL tool with DynamoDB, then to Redshift, and to RDS. By combining your data from multiple sources with databases that all have different functionalities, you can make really, really, really wonderful use of your time. So I find this to be a fantastic way to look at things with a data lake, future of data, big data. What are your future cloud computing careers? The way I look at it, cloud architect for the infrastructure and the knowledge of putting it together, cloud security, because security is a gaping hole in the cloud, mostly due to not people that are configuring things and they don't understand what they're configuring, but it's still a problem. And data science and being able to use this. And data lakes are part of this data science. Where are you going to mine your data from? Your data lake. So think of it this way. Now, the last thing I really want to cover for today is when you're using databases, except for serverless, like DynamoDB and Amazon Aurora, what you're going to be dealing with is you're going to have to put them somewhere. And where are you going to put them? Your databases are going to be on an EC2 instance. So where are you going to store information on an EC2 instance? In an EBS VM. So what kind of EBS VMs do you have? You've got the provisioned IOPS, which is the best access you're going to get. You're going to be your general purpose SSD, which we talked about in depth, and your magnetic storage, which is your standard storage. So these are the concepts we talked today. I'm going to open it up for about 15 minutes of questions because we've completed the content that I think we should cover for today. I see some questions that are actually here, and I'm going to answer these questions, and I'm going to ask all of you. Sister Perez, thank you so much for your kind material. I really do love reaching out to the community, so I'm thankfully happy to be there. Next question, I think I saw maybe another question in here. Please ask any questions you may have now. If somebody asked me to explain stateful again, and I am very happy. Stateful means understanding or watching or knowledge of the connection. So let's take it out of tech. If I told my wife that I was going to be outside, I was going to leave my house and I was going to come back in 1 minute, don't lock the door. If she tracked me out the house and then she had a camera seeing me come back in the door, so she didn't lock it and I came back in, that would be stateful. How? Because she'd watch me walk to my car and she'd watch me walk back to my house, and that would be allowed. That's exactly what firewalls actually do. Exactly what firewalls do. You send your data into the firewall, through the firewall. It says Mike's data went through the firewall. Mike's data is allowed back. So realistically speaking, it's no different than if you left your house and then your house remembered that you walked out the door and only allowed you back in. Where when a stranger would come into your house, whose house would say, no way, you're not allowed in. I don't know you. You're not on the permitted list, and you didn't just leave the house, therefore you're not allowed back in. I hope I explained the term stateful for you in a way that you could understand. Sarkhan, you have no experience with database types, that's fine. And services, when you buy DB services from AWS, how do they manage or change the storage area where your data survives? They don't. Well, you're basically getting an EBS VM and you're storing your data on your own EBS VM in the database. Think of it this way, Sharkan. If you were to just do it on your own, where you were to set up an instance and so you were going to set up your instance and it was going to, and you were going to pop it on a system, and then you would store it in an EBS VM. That's really all these things are, except for serverless. And where it is on serverless, AWS stores it on their own RAID arrays and gives it to you. No different than any other EC2 instance, so don't worry about it, Sarkhan. It's just basically the way you'd set up any compute instance on the cloud. Astute, thank you so much. I'm really appreciative of this. Andrew, yes, we are absolutely going to talk about database optimizations, read replicas, caching, queuing, high availability. We're going to do that tomorrow. We're going to spend a lot of time on that. We will spend a tremendous amount of time talking about high performance, high availability, and all these wonderful things. That's just something that's super important to us, and we will cover that tomorrow. So we definitely will do that, and we will cover that tomorrow. Super excited to talk about it. The average human brain can only remember 4 to 6 things at a time, so I try not to go beyond that, but we will definitely have it tomorrow. What other questions do you have? Any other questions? Anyone else have any questions? Got upwards of 10 minutes left scheduled for the day, so if there's any questions, I'm happy to answer them. Again, when would you use serverless Aurora DBs? Quite frankly, I don't use serverless Aurora DB for anything. I do use serverless DynamoDB, but I prefer to use something where I can move my data in and out fairly quickly. People use serverless and people like serverless, and the reasons people like serverless is because it scales automatically and they don't have to think about it. People therefore would use Aurora a lot. What I like about Aurora is it gives you a lot of the functionality that you might get in an Oracle type database, not all of it, but a lot of it, and you don't have to pay for the license. I also like people like that it's serverless. If you're one of those people that wants a serverless architecture, Aurora is a great place. If you're not one of those people that likes a serverless architecture, then Aurora is not the best place. Sir Ken, my training covers everything that you would ever need to get hired as a cloud architect, and then 20 or 30% more. We focus on what's necessary to get hired. We remove all the fluff, all the nonsense, and everything else, because otherwise it would take us about 4 to 10 years. In our 16-week program, we have to work really hard. My team has asked me to basically to ask you where you all found out about us, so I placed a form if you can. We want to make sure we know how to find you so we can produce content and get it shared. Our charitable mission of free content and free training like this is very important to us. I grew up with an extraordinarily limited means. I worked 3 jobs just to get through college, and I worked 80 hours a week or more when I went to school. And I know what it was like when I had to buy my first MCSE boot camp, which was $5,000 back in 1999. And I remember my 10-day, $11,000 CCNP boot camp, and how much that negatively impacted us. So we try and do what I call a freemium model, and that we try and provide an incredible amount of free training to the community that's basic training. And then what we give our students is something that we would normally charge $10,000 to $20,000 for. We just do it for very little. The reason we do it is I know what it's like to grow up with nothing, and I know what a good knowledge can do, and we are really happy to do that. So I'm going to drop the link to my program one more time. If anybody is interested in discussing the program with me, I'm going to leave access to my numbers, and I will totally do that. For this, here's a coupon code for 20% off if any of you are interested. And if any of you guys want to text me or call me and ask questions about our training, here's my phone number. I want to make sure that all of you guys get hired and get to your goals as fast as possible. You found me on YouTube. Thank you so much, Super Brigadier. A lot of people do, but we're also on LinkedIn. We've been exploring Reddit. We're exploring Twitter, and we want to make sure we know where I have my team focus their time, because we want to help as many people as maximum. Yes, the managed DBs could be better in controlling costs, but they might not be. So it's better to truly, truly, truly know. Balwinder, thank you for being here. Chris, thank you for making sure that you've helped us with these things. Also, make sure you've subscribed and hit the bell. And if you've liked our video and you don't mind giving a like, it really helps us as a business spread our message of free training to the world. And anybody that you want to share this content with, we'd be more than grateful. Please share, please help, please forward, please repost. Anything that you can do to share free content and free training to the world really helps us. Malik, Cassie, good day. You have a few questions picking up with security, especially. Which approach should you take? I would go to the EC Council for training. So when it comes to training, I will probably do a free AWS Advanced Security. I will probably also do a complete and total free AWS Advanced Networking course on YouTube Live for people. When it comes to getting your first cloud security architect job, here's what you need to know. You need to get Certified Solution Architect Professional, and you need to know security. 2 best certifications for security are the 3 are the CEH, the CISSP, and the Offensive Security Professional. They're the only security certifications we ever recommend. We do teach AWS security courses. The reason we do it is so you know how to do these things on the cloud, because the cloud has a lot of weaknesses and there's a tremendous number of workarounds. So these advanced security things are good if you're a security architect like me, and they teach you how to work around the limitations of the cloud. But definitely if you're trying to get your first tech job or your first cloud job, get the CEH or the CISSP. There's a lot of challenges on how to do that. We've got a process to get our students through that, but they're the ones that matter. Stay away from the Security Plus. It's not going to help you. Stay away from the AWS Advanced Security as a primary. As a backup to the CEH or CISSP, Malik, that's great. Don't do it as a primary one. It's just not going to help you. We want to get you guys hired and paid as much as possible, and that's why we're trying to give you this kind of training. Any more questions for me? Any more? Thank you, Taya. That's my whole goal. My whole goal is to take all the mysticism out of cloud computing, all the complexity out of cloud computing, and make it to something that every one of you can do. Malik, I will do some more network training and security training. I'm going to do them via live streams. If the results are good, actually, if you guys want some security training or some network training, please comment in the comment section before the call ends. Please comment security training or network training, or comment security training and then comment network training. And if you're having a good time, please comment Cloud Architect. And I want to know that all of you guys are having a wonderful experience. I have some members from my team that are going to be looking through the comments, and when they look through the comments and the questions, they're going to basically tell me what kind of videos I need to serve you better. So please comment so we know, so my data science team can actually mine this data and help us produce better content for you. We've got 2 data scientists on our team, and we're really thrilled to have them. So Ken, you're welcome. Really, we love doing this. Okay, if I don't see any more questions, Thaja, you're welcome. I'm going to close this, and if you guys want me to do any specific training, please put it in the comment section below. I'll keep the window open for the next 2 minutes. Thank you, Sister Yvette. If we get enough requests, looks like we've got enough requests for network training, but we're always happy to do security training. I also would say, if any of you are from a developing nation where it's hard for people to afford this kind of training, please share these videos with them. I want to make sure we help as many people as possible. So Taye, after my course, if you're referring to my Cloud Architect Career Development Program, we give people the certification training throughout the program to be certified. It becomes very easy to actually get certified when you actually understand the underlying technology. It's very challenging when you don't know what it is, but if I just had to learn S3 and policies and things like that, it would be monstrous for me. But it's very easy for me because I built this stuff and I know the data center things. So Taki, we make sure we get everybody trained through the process of going through our program, and we'll make sure you do a great job. Thank you, Swetha. So happy you were here. Thank you, Super Brigadier. Thank you, Bellwinder. We'll get you some we'll do some soon. Thank you so much, Alonzo. Really appreciate everything you've said, Alonzo, along the way, and everything you do. Drop a link to my program one more time. Keep all the rest of my team happy. And a coupon code. And if any of you guys want to call me and have any questions about training, I've, like a crazy person, posted my phone number on a public YouTube video. That should tell you exactly how much we care about this community. Thank you, V. Matt. Thank you, Theo Q. I've got your information. My team is looking at everyone's comments so they know how for us to best produce content for you. Take care, everyone. I will see you all tomorrow.